Alright, let me do a sound check. Looks like you guys can hear me, so it's good. Let me get my stuff set up so I can see everything. Alright. Give people a few minutes to show up, and then we start with all labs all Sunday. I'm going to start with pinning the first lab. Anybody wants to do it? We're going to be doing automation today. So, make sure I've got the right thing up here. It is labs day. Automation. We can do us some Ansible and automation today. That's what we're going to start it out at. Alright, we'll give it another minute or two, and then we'll get going. Alright, let's go down here to our old streaming default, and before we get into this too much, I'm going to do a little bit of housekeeping real quick. The housekeeping is around Discord. You guys are welcome to hang out on Discord, but we do have a couple of events coming up if anybody wants to go and watch them. On December 2nd, we're going to be doing Ben W is going to come talk data analytics, and he's going to talk about that from the perspective of somebody who's a PhD candidate and professor. Hey Tomato, how's it going? We're getting into labs here, but I'm just doing a little bit of housekeeping first. Just telling you guys about, we got these events coming up. Events are always free. We're going to have our inaugural holiday Christmas party coming up, hanging out, talking shop, just kind of relaxing a little bit with everybody before the holidays come up. I tend to be the type of engineer, I like to work through the holidays. I don't take time during the holidays. I like the holidays because people are all gone, and then I can just get good engineering out of the way. I don't have to do a lot of messing around with user requests and those kind of things. So I kind of actually prefer being around during the holidays, but not everybody's like that. So we're going to do this a little out of the way early so that people still have time to go do stuff with their families. And we're going to do some giveaways and some other fun stuff during that. I haven't figured out all the stuff we're going to do yet, but we're going to do some fun stuff that day. Probably some games and stuff. Even though I don't necessarily like making people do games, but I think people will have fun with it. So it's all team building exercises and that kind of stuff. All right, so Sunday is lab days, right? So we do labs all Sundays. The one thing I'm going to add is I will be adding, as we go, I will be adding to this doc from our stuff that we do. So I'll be kind of feeding through this doc and adding to it. We won't be running through it now, but it'll come up on other streams and stuff. So let's focus on labs, because labs are the whole reason we're here. If anybody wants to do this lab with me, it's pinned. And it's about Ansible, installing Ansible and looking around at the system. So, we've decided as a group of engineers that we're going to use Ansible, right? That's going to be an automation tool that our team uses. So the first thing we needed to do is get it installed on our system, right? In fact, let's go ahead and start it, and then I'm going to go and I'm going to clean up the lab guide on this, because this is a little short, maybe a little too terse, right? So we're going to say to install Ansible, and there's a bunch of other packages that got installed with it. So we might want to go check what other packages had to be installed on the system as requirements, right? Because our package manager will go download all the requirements. And what we can do to see that, if we needed to, is we could just cat real quick the file that keeps a log of all this stuff. So one of the easiest ways to do this is just to cat out, as soon as it gets done installing, we would cat out var log apt log, right? I think it's history log. Yep. And then this is what was added today in our system. Hey, thanks for the follow, Jump Care Love. Hopefully this stuff's useful to you. We are live over here and over on YouTube, although nobody's really on YouTube, so that's more of an exercise than us just playing around over there. But we are building into a system Ansible, and then we're going to go through the labs and look at how to do all the pieces of automation. I think I did these a couple weekends ago, but I mean, it bears repeating, right? Like, doing these simple things will help us to do the bigger, more advanced things out in the enterprise, right? So here's what had to be installed for Ansible to have all of its dependencies. A lot of Python stuff, you'll notice. I mean, Ansible is written in Python. And then somebody just showed me the other one the other day. There's an Ansible clone written in Rust. It's called JetPorch. Yeah, so if you look up, some people want to use JetPorch, and they want to do it that way. So there is a tool out there called JetPorch, and I'll link it to you guys if you guys want to use that. I'm going to tell you the industry leans heavily on Ansible, so feel free to use Ansible if that's a tool that, if you're looking for automation. So we can check our version. We're on 2.9.6. That's the version that comes still to this day with the repository of, the default repositories of both like your Red Hat systems and your Ubuntu type systems, right? So boom, there you go. They give you some information. Where's Ansible going to look for its configs? Over here in etc Ansible config. You can override everything in this file with a local config file. So in whatever directory I'm in, if I wanted to, I can override values that are in this file by having a local file, even a local dot file. So this is a common thing for people to do. Like, I want something to behave differently than the norm. I want to have like a set of forks or something. I can go and do that. So if I cat etc Ansible Ansible CFG, let's not cat it. We'll just grep it. You could also just grep for fork. Let's say we look for fork. Forks by default is 5. So if I want to override the default of 5 forks, I can do that in a local file in this directory here. Even a hidden, something like that, which is a hidden file, right? You have to use an ls-a to see a hidden file, right? And the reason we do that is because sometimes you want the behavior of just this one playbook that I'm doing to act differently than the default. Maybe I want the host file. So there's a default host file out there, right? And the host file that's by default for the inventory is that's the Ansible host. But maybe I want to make sure that everything in this directory is going to be like the host file in here, or the, stream underscore host is my inventory file that always be used. I can hard set that in here, and I can override it right here. So that's kind of like an important thing. Some of you guys are used to like pulling in like default variables in a programming language or something, or you're like used to getting environments, but then you override the environment. Well, this is the default of everything for Ansible in this system now. Hey, how's it going, Last Chain? We are going through Ansible stuff. The link is up if anybody wants to do it with us. We've installed Ansible and checked the version. And now I'm just talking a little bit to some of the config files. I actually probably want to add these. I'm gonna take some notes over here. And the notes I'm going to add is Ansible. So I'm going to say Ansible Lab 1, add in a description at top. And then I'm going to say so I need to add that in. And then I'm also going to say to add in the discussion on Etsy Ansible. Ansible.cfg. Add in the discussion on default location for Etsy Ansible host file. Because that's important. That's like an important thing for you to understand. I want to catch up. Thank you. Yeah, well, we're on the first one. So, mute time, thanks for coming by. We are simply on the first lab, and I'm simply pressing buttons and then telling you guys a little bit about how Ansible kind of works, right? So we come down here and we can take that version that we popped out to the screen. By the way, you see the Python version that it's going to use as its interpreter on this machine is Python 3.8.10. So that's the version of Python that it's using, and here's the version of Ansible. The Ansible version, we can throw that into a file called root version, and once we do that, we can move forward in the lab. Lab's not going to let you move forward until you do that first part. Now I say check the Ansible doc and see how many modules you have. Then read the documentation for the module setup and copy. So setup is going to let us do some things and copy is going to do some things. We can figure that out in the lab. And then it says save the number of modules you have into a file called root modules. So we say Ansible doc help, and that's going to give us a bunch of information about Ansible doc. So Ansible doc is one of the many things that gets installed when you do Ansible. In fact, if you type in Ansible on the system and hit dash and then hit tab a few times, you will see, you should see, oh, it would help if I spelled Ansible, right? You will see all of the different things that got installed. And we're not going to do all of them right now. Oh, excuse me, I'm not going to look at all of them in this lab. We kind of hit a lot of them as we go, but through the different labs. But I want to show you guys that they're there. And I want you guys to be thinking about how you might want to use them. And you can read the help pages for any one of them, to get information. But real quick for Ansible doc, it says that if we do a -L, it'll list all the available plugins, including modules and those kind of things. So I'm going to say Ansible doc -L, and this is just going to dump way too much stuff to my screen. Way too much information. In fact, I have to hit Q. How much information was it? I'm going to type it through a word count -L, and I'm going to see that it's 3,387 lines of system information, of modules and things that can be added or removed into Ansible, as you call it, to make it behave different ways. So I'm going to take that, I'm going to throw that into a file called root modules. So now if I'm more on root modules, I'll get the output of 3,387, because that's about right. And then we want to go read one of them specifically. There's this doc for setup, and we can go and read that setup is going to gather facts about remote hosts. It's actually using Factor on each system, and it's gathering data about them. You can do a specific fact path if you know where it is, and it's based on JSON format. And then we can also filter, and we can use an FN match style wildcard, and we're going to look at that in a future lab. And then you could also, instead of gathering everything, because what's going to happen when you do setup on a system is you're going to get about, it's like 16 pages of just data for each server, and that's going to take a lot of memory. If you start getting up around thousands and thousands of servers, it starts to be a lot of variables being held in memory. So you can gather a subset. You can say, hey, I just want the network or the virtual or just this factor portion or just the hardware portion. And you'll get a subset of all. Typically, by default, you're going to get all. And we're going to run this here in a little bit to see what the output looks like. I'm not going to leave you hanging on how factor works and how setup works. But I just want you guys to see that for right now, we can just read information about any of these pieces. So I'm going to hit Q. and it's going to go ahead and then we'll read the document for copy. Copy is going to copy files to remote locations. That's what the module does when we call it. There's a bunch of things in here that are optional, but things that are required are the source and the destination. So here's the destination. Where you want to put a file is very important if you're going to call a module that puts a file somewhere, right? And the other one is where you get it from, which is the source. Now you might say, what's the difference between source and remote source? Well, source always has to be there because it's where you're getting it from. But Ansible assumes source to be on your machine. That's the default, unless you set remote source to true. If you set remote source to true or yes, it'll be looking on that far machine for information. So you might say, real quick, I'll pop myself up here. You might say, Scott, why would you ever do that? Don't I always, from my Ansible machine over here, want to push some file to this other machine? And the answer to that is no. Think about this. You're copying an ISO into a temporary directory over on this machine here, right? So here's your machine, here's your server, your Ansible server. And this machine over here is one of 1,000 machines. So he's just sitting here. He's a bunch of machines. And you want that machine, just think about this for a second. Your Ansible machine on its 1 or its 10 gig management port connection into all of your like high performance compute systems is going to have like, let's say it's got a 10 gig Ethernet. And you're going to push like a 4 gig ISO to all of those machines from this one Ansible machine. That's insanity. What would be better is tell the machine, hey, you know what? Pull that NFS ISO or whatever that ISO you want to get, but pull it over your locally mounted NFS link, and then all of your machines are maybe hitting an NFS link, or tell them to pull it out of GPFS or Lustre where you have it staged, and they'll be pulling it over an InfiniBand link that's 400 gigs per second. That's a lot faster, guys. Way, way, way more fast. way, way better. So one is a push model to all of my nodes, and that can be extremely bottlenecked by the speed of this one machine. And the other way is all those nodes over there, they look on a local source, but it's really a mounted remote source, and they pull the information to them. It's a tremendously fast way to manage a bunch of systems. But all these advanced things I talk about come from your basic understanding of it, which is why these modules start. Hey, Alchemist, thanks for stopping by. We are going through Ansible. We're starting with it. We have a bunch of modules. Sunday is all lab days. That's all we do on Sundays is labs, right? So I am going through this, and let's see. So here's our questions here, and this is install. It's going to be install and inventory. Make this a little wider here. Put this down a little bit here. Maybe even pull this. Ansible install inventory, and the first question that I'll kind of ask is, what is the can you? And so all these are questions, kind of like we're kind of going. Yeah, thanks for that, Alchemist. We're kind of going through this as though we're doing what's it called? The Socratic method. So I'm asking questions and you're responding and those kind of things. When we get to this, we're not doing these right now. But right now, for this one, it's what can you show the version of Ansible? So can you show the version of Ansible? We just did it. We know how to do it, right? We're going to duplicate that slide because there'll be more questions on it. So we did that, and we checked the two things here. So now we can go on to the next part. And that's the whole lab. The lab says, look at you learning Ansible. You solved this challenge. It's straightforward. Can you install Ansible? Can you look around at some of the commands on it? That's the whole lab. That's a whole of what I kind of make you do there. Okay? So over here, though, where we're asking the questions about it, we got to learning Ansible through the Socratic method, install and inventory. Can you show the version of Ansible? Let's see. What's another one? What's another one that we might need to do? Can you show me the documentation for let's say the documentation for the, which one do we want to do? Let's do URI module. And we're going to grab all this and we're going to make it slightly smaller so it fits. Can you show the documentation for the URI module? I think that's a good one. Because if you did any of this, you should be able to just go, yeah, here's the URI module, right? And then I see, oh, here's some attributes and here's some stuff that I can do. I can start to figure stuff out about information that I can pull out of Ansible. Now, one of the things I've told you guys that I've used Ansible for, I've used it for all kinds of things in the industry. I mean, mainly maintaining 5,000 servers in different locations. That's mainly what I use Ansible for. But one of the reasons I use the URI module, which the URI module will just let you go interact with web services, including APIs. Mainly what I would use it for is to go hit the API for satellite and to pull an inventory of my servers every day. I would pull an inventory of my servers, I would carve them all up into their different host groups, and I would build an inventory daily that showed me everything that was going on in my Linux environment. So if you said, hey, can you show me the difference between all the servers today and all the servers that you guys had inventoried last Friday? I'd say, yeah, I could do that pretty easy. Just do a diff between two files. And I would immediately show you that, like, the production systems had grown by 3, non-prod systems had 20 more because we allow people to just push a button and build a non-prod system. So yeah, boom, there you go. This is all the differences. And they're like, okay, yeah. We saw that there was like a 30% growth in that space, and then we see about that much added. Okay, good, that's what we expected. 30% growth would be kind of big, but I'm just throwing out numbers here. So okay, so we did that. We built that first challenge. I'm gonna go down here and say Ansible Lab 2 in case I have anything to add to this one. And let's go start on the second lab. So the first one was to install Ansible. That's always been true for us. The second one, I'll link this one for anybody that wants to do it with us. Let me unpin this one. Unpin now. And we'll pin the new one. This is going to be lab 2 for the day. I always tell you guys, we want to learn how to do this, but not a lot of people want to learn the basics, right? Like, when you learn the basics of the thing, you can go build whatever you want off of those basics. The basics of any automation platform is 1, getting it on the system, which was the install, and 2, having a good inventory. If you don't have a good inventory, you do not have your system administration in place, and you do not have your system security in place. You simply don't. You have to have a good inventory, or otherwise, what are you managing and what are you protecting? You don't have that. So that's not me like getting up on a soapbox. That's just simple facts. Like, you have to have those things to be able to manage your systems, right? So this one says, hold on, I gotta add a header description. I've been meaning to add a better one of those for a while. All right. This one says, create an Ansible file called root hosts with the hosts in your network. The hosts that you have here are control plane, hostname, and node 01. Those are your 2 nodes. So we got to turn them into an inventory file, because everything we do, once we have an inventory file, we can manage all of those systems. We can see if they're available. We can check them for values and any kind of things we want to check on those servers, we can do once we have them in the inventory. Before we have them in the inventory, we can't do anything with them. So here's the solution. It says what to do. We're just going to vi root hosts, and we're just going to make a server. We're just going to make a host group called servers inside of there with control plane and node 01 in that file. So if we cat root hosts, we're using control plane and node 01. So here's our inventory file, and here's our host group list in INI format of control plane and node 01. All right. If you need to know more about inventories, you go to Ansible inventories, right? Something like this, how to build your inventory, and you can go read about it. Some people, I'm not saying this is wrong, I'm just saying this isn't the way I do it. This is the INI format. Very common format, been around since the 80s probably. And then, I don't know, that's when I've been around since was the 80s, but this has been around a long time. And some people really like it in YAML format. The reason I use this format is because when I was, that example I gave earlier, when I used to call satellite and hit all my servers and then I'd get lists of servers grouped by things that I had created, I just wanted to be able to put whatever value tagged to the top of it and then generate the list underneath it. And this was the easiest way for me to do it, was in this format. Some of you probably deal with unstructured or YAML is a semi-structured data format, right? There's structured, unstructured, and semi-structured. Those are the three types of data formats. YAML is considered a semi-structured data format. Some people like looking at it like this. It's the same data here. I prefer it like this. It's easier for me to generate lists like this than it is for me to do it like this. But for some of you that probably play in that space all day, reading in and sending out YAML or JSON files, you may want that. But you can't use JSON as a inventory format. You can output in JSON format, but you won't input into Ansible with it. And I'll show that here in this lab here in a second. So that link is there. And again, we're doing really basic stuff, but these basic things are going to build into all the other things that come out. So now it says verify connectivity to all hosts. So we've got these two hosts. Let's see if we can hit them with the ping module. So the ping module inside of Ansible works like this. It's going to connect to both of those machines over SSH. It's going to push the Python microcode, and in the Python microcode of the ping module, it's going to basically print out Pong and then bring that back over to me. It is not an ICMP ping. ICMP ping looks like this, right? And that happened up to layer 3 of the OSI model. It pinged the system based on its name. It made sure that it got, from an echo request, it got an echo reply. That is not what happened in Ansible. Ansible did a totally different thing. And if you said, could you prove that? Yeah, come over here to the left and just add -VVV to this. Add a bunch of V's on there. Three is enough. And watch what Ansible's actually doing. You'll see the SCP connections. You'll see the SFTP connections over SSH, where it push actually might just be SCP. Now that I think about it. Oh, it is SFTP there. Yeah, you'll see it push the data over as that file. And you'll see it actually push the ping.py microcode over there, and then it'll go run it. And then it'll get the value back. And you can go look at this. This is debugger stuff we only tend to look at in any type of automation or programming when something goes wrong. But this is also useful to prove to ourselves that we are doing what we think we're doing with the system. And you might say, well, if I never want to know and I only pull it up sometimes, why do I want to know it's there? The reason as engineers we want to know the exact way things work is because if it breaks, we have to go look at where it broke. That's why. Otherwise, I don't care. I can just run this. I got a ping and a pong. I know the two boxes are up. I go about my day. I never think about all that other stuff. That stuff is only if there's a problem. And that's kind of like the crux of engineering, where when everything's good, we're basically running around like sysadmins. When everything's good, you know, we build stuff and we do stuff and you know, whatever. But it's because of things breaking that we have to know how to get in there and look at them. And I tell people all the time, if systems just worked out of the box, they wouldn't need engineers. They would just have salespeople set it up, and then they would go on their way, and that would be it. That would be the end. There would be no engineering. Engineers are there because we understand how a thing works. We strive to understand how a thing works, and then we find where it breaks, and then we fix where it broke so that the process can run. I have a talk that I do on that, which has to do with like soft skills in engineering and understanding your value in engineering. I have 2 different talks on it. But the thing is, I want you guys to know that like the way these things work, it's very kind of important to know and look at. So I'm going to take that output and I'm going to throw it into a file called root ping check. And that's going to, if I cat out root ping check, I should see that it found and was able to send over that code and get an output on both of those boxes. So what can I surmise from that? My inventory is good because I hit the 2 servers that are in my inventory. Those devices are up, they're turned on. They have SSH running. We have proper authentication to get over there. And then when the execution of that thing with the correct permissions it happened over there, it has Python over there to be able to run our code. Those are all things that I know, and I don't have to go check if there's a problem. I know those things are there. Right? This is what we do as engineers. We trust but verify. We have truths that we can then prove, right? Like if anybody remembers that from geometry class, you had these proofs you had to do, and you had to say, how do I know that this angle over here is the same as this angle over here? And you had a bunch of lines on the paper, and you had to prove that this was this. Well, we can prove a lot of things to ourselves. We don't have to write it down. Like I don't have to write down that I know those things, but I have to know them in the back of my head so that if something breaks, I can go fix them. So, this is a class. This is us doing labs on Ansible, but it's engineering methodology 101. How do we think? What we do is we think if everything works, we're good. If everything breaks, I need to know how it broke. And I tell people all the time, that's the difference between an engineer and an admin. An admin understands what they're doing typically. An engineer, the only thing added to an engineer is two things. They know why they're doing the thing they're doing. Engineers and admins do the same thing most days. Like keeping the system running, right? Engineers are always falling back into admin roles. I don't care what project you're on. You're going to have to go run the things that you ran and stuff. But the other difference between most engineers and admins is about 80 to 100K a year. That's the other difference. Engineers make more. Admins are running the system, but engineers know why the system's run the way it does. Almost all other ways, there's not much difference. It's just a pay gap, right? So I just need you guys to know that because that's kind of a truth of these systems. All right. And you can look at that as morbid as you want. You can look at that as Chad as you want. It's a fact. It just is what it is. And if that's going to be a fact, I'd rather be on the engineering side of it than the admin side. So, and the more you do this stuff, the more you're going to move towards engineering anyways. So, all right, your team's going to be adding new servers to an environment that haven't been built yet. Update your inventory file at root host to reflect the new environment. So now I said to update this file. So vi root hosts, right? And Shift G to go to the bottom, hit O, and I say, show me the new servers. Show me what new servers exist that I have to add. I'm just going to grab them right here. This is all new stuff. I'm going to hit Control C, Control Shift V, because we're pasting into a browser environment. So it's a little weird. And look at all these things now in our inventory. Escape::WQ. I can cat the file so I can see it. And here's our original nodes. Here's test environment nodes that don't exist yet, but they're there. And they also have these assigned variables of type on them. And then there's these prod environment servers called control prod and control, or node 01 prod. And they've got some types to them as well. And then we've got this special one here called non-prod and its children. This one inherits servers, the original list, and test environment. Because both servers and test environment fall into non-prod, they are not a production system, right? And by the way, your company's going to define that however your company defines that. So that's something for you to kind of learn how your inventory goes. These are all things that could be coming. They're not here yet, but they could be coming in our environment, so we added to them. And then I said, now that you've updated the inventory, view that inventory with the Ansible inventory command to see the host groups. So now I'm going to look 3 different ways at the same information. And before I do that, I'll let you guys start working on that. I'm going to come over here and I'm going to say, okay, can you show the version of Ansible? Can you show the documentation for that module? And then I'm going to say here, what can you output the inventory in 3 different formats? So we're going to do that right now, but I asked that in the lab environment here. Can somebody view this in 3 different outputs, right? And if I go up here, if there's anything else back here I want to see. Let me go back one. Hold on real quick. Okay. Yeah. All right, so we've got our inventory file here. If you're tracking that far, by the way, the lab is up there. You guys can do the lab with me if you want. These labs are always up on Killer Coda. I get nothing from you guys going to the labs except the, good feeling of knowing that people have been going to the labs. The one thing I get out of it is this right here. Again, it's not monetary value. On my creator dashboard, I can see the activity, and I can see how many people have kicked off these labs in the last hour. If anybody's been doing install Ansible with me or install Ansible host file with me, they would be showing up here. The last 24 hours, the last 7 days, the last 30 days, and then for the month. But this is November, so we don't have as many in November yet, but we're only halfway through November. So the goal is to keep these numbers pumped up, right? And how many people have been starting our scenarios and working through these different topics that we have out there, right? Okay, that's the only thing I get from you guys doing these labs, except for the knowledge that you guys went and did the labs. All right, so let's go look at that inventory file, and let's look at it in a list format. This is what it looks like in a list format, if we just say list. And if I look at that, and if I were to ask you, what is the output format of this? How has this been output? All gets children. Children is a list here in a list output format. Does this look like any semi-structured format that you guys might be familiar with? That's definitely a semi-structured format of some type. There's non-structured data, which is just you throw data. It's like a story. And then there's structured semi-structured formats, which are like your JSON and your YAMLs. And then there's structured, which is the most structured, and that's rigid things like your database schemas and those kind of things, right? And what is this? This is definitely a JSON output right here, right? And then how about this? We can look at it in graph mode. Graph mode's cool to look at. That's kind of nice to look at. In fact, for us, I could take that and I could grab this as a snipping tool like this or something, and I could say, here you go, guys. That's a real nice thing to show my project managers or something. But this right here is absolutely atrocious to send to a system. A system can't parse that out. A system can parse JSON pretty well. There's all kinds of tools for it, all kinds of stuff like that. And there's one other way. You can also say, I want to see it in YAML format. And YAML is, YAML's probably the semi-structured data format of choice, right? Like people love parsing this stuff out. All three of these outputs are the same actual data. They come from this same file you just created. So there are three different ways to look at it. There are three different ways to maybe pull that out and feed that into some other productivity tool or some other thing that you have. And I'm not going to tell you how to bake your pie or how to make your muffins at your organization, right? You can do it any way you want. I'm just going to tell you, find a way that works for you and make that your way. So the reason I have all these here is to show you the different types of formats that exist. The most useful one for me was always this. I'm always best with these any formats. So that's what always resonated and made sense for me. It says, look at you learning Ansible. You solved the challenge. You built an inventory file. You then used it to connect to the servers with that ping command, which was a ping and a pong in Python using Ansible. You did not use ICMP ping. You then added additional servers for the environment and viewed them with the Ansible inventory tool. That's good. And then over here on the questions, we're just making up the questions and we go. Can you output the inventory in three different formats? You could. Yeah, you could. So I think that from this standpoint, install an inventory. We showed the version of Ansible. We showed the documentation for the URI module or any module with that thing. Can you post the output in three different formats? And then what other ones? What other things could we ask from that? Let's see, what can you assign variables to the servers in your inventory? So can you assign variables to your servers in the inventory? And the answer is yes. We're not doing dynamic ones now. These are all still static. In fact, I don't think I've ever in an enterprise used a dynamic inventory in the Ansible sense of a dynamic inventory. What do I mean by that? Did I pull the inventories every day dynamically? Yes. So they were dynamic inventories in that sense. But once I pulled them dynamically out of Satellite, I set them as static inventories and used them in Ansible. A dynamic inventory in Ansible is like you go out and run a script or a Python, execution of some type. Even playbooks can build them, and or you go grab it from somewhere and it generates it on the fly, and then you use that generated inventory to do something. I have not done that professionally. You may even call that a control freak problem, but it's not really a control freak problem. It's more of like, as a systems engineer, we try to control things. It's the same thing, same reason why we always download stuff to repositories like Satellite or Pulp before we release them to our environment. I don't want my servers going out to the world. Never. Absolutely never. No enterprise server should ever pull shit from the internet, ever. Full stop. It should always pull data from a trusted repository and pull it in. Have I used Ansible to create some type of state files? Yeah. Startup me, yeah. So I use Ansible to set facts on servers. I do it in, so that inventory, this file's done. Yeah, so hold on. I'm gonna link this to you. We're not gonna do this one yet, but I use it right here, push facts to all servers, and then I use those facts that are on the servers to group the servers up. So to answer your question, that's the one that does it. And let me explain to you why I do that on servers. Because when I run playbooks, right, like as a enterprise, like I've been a platform engineering lead for AAA, which had about 5,000 servers, both Linux and Windows. And what would happen is on a patching night, we would get whatever servers were released from the CMDB, the configuration management database, and had been approved through our change process and had been allowed by those teams to be patched on that night. So it was almost like at the top of a Plinko machine, if you've ever seen where they open up and just a bunch of little steel balls fall out and fall through the things like this. It would essentially amount to this. I didn't know what servers I was patching until it was time to patch them. So what I did was I took the approach of like Marcus Aurelius in Gladiator. I don't care what comes out of that gate. If we stick together, we know what's going to happen. And this is what I would do is my servers know things about themselves. My servers know that they belong in specific patch groups. My servers know these things because I've stamped those variables to the server in a facts. So it's etc ansible facts.d and then like a patching.fact playbook or a fact file, right? And as those servers get dropped in, whether it's 5 of them or 50 of them, they immediately sort themselves out into their inventory groups based on facts that they know about themselves. So the playbook, when I started the playbook, I'm like a catcher sitting there watching, and I'm like, I don't know what's coming out. I don't know what servers I'm getting. But as soon as the playbook starts running, it goes and it looks at all those things that I've stamped on those servers for the patching groups that they belong in, the high availability groups that they belong in, because I know I have to roll through those, and I have a bunch of logic later for that. So I haven't done dynamic inventories like what you guys are probably thinking, but I've made it such that my servers, it's almost like the servers are a bunch of kids just walking to the school bus and they've got their little lunch pails, and those little lunch pails I can read and tell, hey, you've got a ham sandwich and you've got like an orange juice drink, you go sit over there. Hey, you've got a tuna sandwich and chocolate milk, so you go sit over there. And I can sort my servers on the fly from whatever they give me, because as engineers, guys, we don't control. We control everything we can as engineers. And the reason we do that is because, not because we're control freaks, some of us are, but like it's more because we want whatever it is that we build to work. And the only way I could make sure that whatever they threw at me, because I don't know what the business is going to give me. They could give me 10 servers this month, or 50 servers, or 2,000. Whatever I'm allowed to patch, I'm ready, and those servers are going to bring their little lunch pails, or like little QR codes on the side of their lunch pails, and I'm going to scan them and move them different directions through my playbook. And my playbook is I always call it painting with a wide brush. Painting with a wide brush goes like this. I try to hit 95% of all cases. Now, you guys have probably heard of Pareto's rule. This is in engineering. And again, this is supposed to be all labs, but we're going into a lot of like generic engineering stuff. Pareto's rule, or the Pareto principle, is the idea that 20% of your inputs are going to cause 80% of your outputs or problems, right? So what the Pareto principle is for me is in systems world is some of my systems are going to cause problems, but I can paint with a wide brush and try to hit like 95% of them. 5% of them, which 5% of 1,000 is what 50 servers. That's still a lot. Are going to just not work right, and we're going to have to do some other thing. But I would rather be fixing 50 servers than trying to manually patch 1,000 servers. So there's that. Yeah, 80-20 rule is the Pareto principle, and you'll find it varies in practice, but it's an absolute essential thing to understand if you're trying to build automation. So, what happened? Hold on. So I'm thinking about creating some kind of playbook to map continuously the container's distribution. Probably can be done in the container D LVL with kubectl. But my company is running containers on top of VM. Don't ask me why. This happens. Look, OpenShift when I was at AAA, and my brother still runs OpenShift for AAA, which is CSA, the insurance company. My brother's still their lead over there on that. They run that on top of virtual machines as well, so that happens. Don't ask me why. So there's underlying OS can be relevant for catching problems. Yeah, I agree. Startup. One of the things that I do too. So I need to write down. Like I've been building stuff for systems administration for a long time, but one of my things that I really think works well for system administration is the same thing that you see like ranchers do. And not that we see ranchers do it, but I'm saying like I don't know, some of you guys watch Yellowstone. I didn't really watch Yellowstone, but I heard about a big cult phenomenon, like everybody in the culture phenomenon, like everybody in the country loved it, right? But if you've ever seen like how a farmer will go walk his land every day just to make sure all the fences are up, make sure his cows can't get out. It's this same kind of idea to me that like every day as a systems administrator, I think you should touch all your systems. Now, should you do that by hand like this? Probably not. Should you even do it by like a shell script looping over? Probably not. That's still kind of tedious. That could still take all day for a few thousand servers. So what I do instead is I use Ansible playbooks that report stuff out, and then I report it out. I have it in our Discord. It happens in our Discord. I have it in our Sandbox channel, but professionally I tend to send this to either Slack or Teams. In our Sandbox is just where we throw stuff. We have webhooks and stuff. And in our Discord, you can get our Sandbox API, our webhook, basically the API, and then you can send data in here. But for me, like I'll do stuff like if something reboots or something alerts in my environment, it sends something out. And you would say like, well, why would you do that? Why would you want to know if something happens? Like why, what might you want to know about that, or why would you want to know that? Well, I want to know every day. If I have 1,000 servers, I just want to know that I can touch them every morning. And if my and by the way, I'm not going to touch them, but my servers are going to touch them, my Ansible playbooks and stuff. And if anything doesn't come back good, just post it right here. And I used to do this. I did this at Best Western. Right before COVID hit, I was their architect for like all their Ansible stuff, and I was deploying all this stuff. And one of our guys, Pico, is still around. He still works for him, and he's kind of taken the mantle of all the stuff that I was doing. But he and I, we wrote this thing out where we would just check every morning. We would pull stuff out of, there's a tool that they use called Surewell, just an inventory management, and then we would pull stuff out of Satellite. Satellite was getting updated every day with people building stuff in AWS and stuff being built on-prem. But Surewell wasn't always getting updated with AWS. So we were getting these disparities. And every morning I just built this inventory. It would go out, it would get its token from Surewell, it would get its token from Satellite. Actually, it could just log into Satellite, didn't need to get a token. And it would get these two inventories, it would compare them, and we would see 3 more servers in Satellite that weren't in Surewell. And then we would go to our architects over on the AWS side and say, hey guys, that process isn't working again. We need to get that fixed. And then we would get it fixed right away. And then we would just have clean outputs every day. We would have clean outputs of our servers are the same in both inventory places. All of our servers are up. And all of our servers have all of the agents that we expect to running. They run Chef in their environment. I don't think that really matters that anybody knows that. That's their configuration tool. So they've got Chef. I think they were moving away from it, so they probably don't anymore. This is years ago. If Chef has an agent down, or Puppet has an agent down, you don't have access to that server. You guys know that, right? If you have 100 servers that are in Chef, but like 4 of them aren't running the Chef agent, you're only hitting 96% of your servers. You guys know that, right? Same thing with Puppet. If you don't have a Puppet agent on, 6 of your boxes, you're only now hitting 94 of them. Ansible's different than that in that Ansible's not agent based. If Ansible has SSH, it can get to your boxes. It still needs permissions. There's all these other things. But my point is, Puppet and Chef are agent based and they require that. Well, what if every morning we would just check, and instead of sometimes having, and guys, if you've ever been in an environment, you 100% know this is true. There's like 10 servers that are always just like down for some stupid reason. They have their temp got full and something stopped running, or they filled up their var partition and then it couldn't write its whatever, Prometheus couldn't write its shards out anymore because var got full. So that we would clean this all up, and then we would just have this clean thing every day that wrote out into it was a Teams channel for us, and it would just look like this, and it would be a clean output, and it would say no servers are unreachable, no servers exist in Sharewell that don't exist over here, no servers exist in here that don't exist over here, all servers that are running, or all servers that are not running Chef are here, and we would clean that up, and then it's almost like if you guys ever drove an old Bronco on the freeway and you have to go like this the whole time to keep it on, to keep it going straight because there's all this jankiness to the steering wheel. It's that same idea that systems administration is super simple if you keep it going straight. But if you let your system start going like this, you're probably going to roll your Bronco, right? Ran this shit as sudo and created the top of the wrong user. And created on top of the wrong... Yeah. And by the way, guys, the reason, I think I've told you guys this before, well, I've definitely told the stream this before, one of the reasons I got into using Ansible, the actual main use case for me, was I used to work on government systems in the FedRAMP, which was the cloud for a bunch of different states to run the Affordable Care Act, and this was like back in 2013. And we were not allowed to use root keys to hit all the boxes. You had to go in as your user and sudo up. That's the exact use case for Ansible. I can be my user, run a password inside of Ansible and hit a bunch of boxes. So I go in low as my user, sudo up, do my permission, do the things I have permission for as root, drop back down and leave the server. It's like a super, it's probably the best original use case I've seen for Ansible in a system. But anyway, so to start using this as an automation tool, the first thing is you have to be able to install it. You got to get Ansible on your box. And then you probably need to know some basics about it, which is what this first lab was. The second lab was the next most important thing to getting it after getting installed, is getting a good inventory, because a good inventory makes everything else in your life easier. Now we're going to start doing some commands. We're going to start doing some ad hoc commands that are going to make sure. So I'm going to link this here, pin this. I'm going to link this for people that want to do the lab with me. Labs are free on Killer Coda. Don't charge you nothing for them. I couldn't charge you for them if I wanted to. There's nothing to charge. It's free. Killer Coda, the only thing Killer Coda ever asks is if you want to buy their $10 a month thing, you can, but you do not have to. I've been using them. I've been building labs on them for a year and a half, and I've been using them for... I started using them in June of last year when I was getting ready for my CKA and my CKAD. That's why I started using them. They've never charged me anything. In fact, I don't even think they send me that many emails, so they're not even like always trying to push anything on me, All right. Get my fan over here pointing at me a little better. So, let me make sure I'm not missing chat too much. All right, let's keep going. This is the lab. We are now moving into the next part, which is, can you use Ansible? These are just my little things that I'm typing. Can you assign variables to your servers in your inventory? Okay. Can you assign variables to your servers in your inventory? That was part of that last lab. All right, so then we go into ad hoc topics, right? And I'm just building this as we go, even though we have all the labs already built. I'm building that for something that's going to run later, as we kind of integrate those into the streams in the future. All right, so let's do this. Lab activities. Verify your host file and test ad hoc commands into your servers. We're going to verify all the servers' uptime. We're going to see how long the 2 servers we have been up. So real quick, while that's running, cat root hosts. Boom, there's our inventory file. It's built for us already. And then let's see if Ansible is here. Ansible is there. So we've got the 2 things that we need. Now we're going to use some ad hoc commands to verify the server's uptime. We're going to verify the OS type of the servers, and then we're going to verify the date and time on the servers. There are so many things that you can get out of the servers with like the setup module. I think I even show it here, but it's just, it can dump so much information to the screen. It's about 16 pages of server. It's just a tremendous amount of data that you could then use for all kinds of decisions in your playbooks. And we'll get into all that later. But for deliverables, we're going to create a file called root versions with the Ansible facts for the distribution of each server. And then we'll create a root date with the Ansible facts for the current date and time of each server. Okay? So first thing we do is we cat root hosts, and we see that that's there. Good. And then we're going to run a playbook here. And this playbook, playbook, sorry, it's an ad hoc mode, an ad hoc run. And we're going to call the server's host group. So here's the server's host group in the inventory root hosts. And we're going to call these two nodes. And we're going to ask them with the module shell and the argument uptime. What's your uptime? By the way, with the shell module, you can ask anything you want here. But there's a limitation. There's a problem with using the shell module. And I'm going to tell you what that is. In Ansible, we want to control things, right? I keep talking about like having a grip and like controlling things. And all the other modules that we can use, for the most part, have some type of control where they can check first before they execute things. Or they can check all kinds of things. They can do all kinds of things. But what we can't do... Hold on real quick. Also, I'm going to mention we have a YouTube. If anybody likes watching over on YouTube. Nobody's watching on YouTube, though, so it doesn't really matter. But the problem with shell is this. You have to loose that control to use shell. Shell is Ansible firing cannons off into the night. And I don't know if any of you have ever heard a cannon be fired off into the night. But when you fire a cannon, there is no way to unfire that cannon. When you launch a cannon, if there's something, a mile away in the trajectory of that cannon's ball, it is about to get hit. There's no way for you to undo it. Whisper 12-foot gun, yeah. So, shell command simply executes a thing and waits to get data back from it. And it's a loss of control on the Ansible side of things. All your other modules can do checks and then run and then retry and whatever else you want to have inside of the module, and Ansible maintains control the entire time that the module is happening. The shell command is not like that. The shell fires off into the night, and it always fires. All right, so there's that. Something to think about. By the way, we had to do the YouTube because people were like interested in watching stuff later, and I don't really keep the VODs on Twitch because I tell you guys, I want to make stuff that's valuable, right? And me sitting around and talking isn't always that valuable, especially if I go off on tangents and stuff. So I want stuff to be like very valuable. By the way, because some of you are probably wondering, I have already this morning, well before I got on, finished all of my college teaching stuff with my students, and I've done all my going to college stuff, right? Because I'm working on my doctorate for business administration right now. So I'm like very busy, but I did all that stuff before I got on stream. So like this is the kind of things you have to do, I think, as an engineer. So now the setup module is going to give us a bunch of information. So let's run the setup module and see what's going. How often have you been required to develop Ansible plugin modules in Python for a company? Whisper, I've never had to do that. I've modified plugins a couple times for myself within a team, but that you got to make sure when you do that you capture that and you make that into an environment. So you can have different execution environments when you get up into like Tower and what's called the Ansible automation platform now, and you can make your playbooks use certain environments, execution environments, they're Python virtual environments. That's exactly what they are. You build a Python virtual environment, you install all the things that you want to be there a certain way, and then when the playbook runs, it runs with all of those modules. So like if your playbook needs URL lib3, but it wasn't there by default in Python, and you wanted to use that instead of requests or something, you could do that. You could build it in to that environment and it'll always be there. And I got asked in an interview, and I was like, I don't have a need for it. Use community. That's Whisper. I've never had to do that. But that company may have downloaded or went with a third-party thing, and they have a need for somebody that can do that. Now, is that super difficult? Not really. You got to read some man pages. You got to be comfortable enough to run some Python, and then after you modify stuff, you have to be able to extensively test it. That's all that is. So they were asking you for something that I would say is a very, 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 very small use case, but it's probably something they've run into. So they just wanted to maybe see if you had that experience. I've only maybe done that once or twice in the last 10 years of using Ansible, and because most of the community stuff is good enough. They probably had some very specific thing, or somebody had done that, one of their previous admins, and they needed you to come in and fix it or something. But it's not that hard. Not that it's not super complex, and you can go read some blog posts on it and do it. It's not an impossible thing to go uh, fix and get working. So, all right, let's run the setup module. This is the one that I told you. This is going to pump so much to our screen. By the way, guys, this lab is pinned right there, so you can do it with me. I don't do these labs for my health. I don't do these for my own edification. I do these to help you guys learn how to do this stuff. So if you tell me, hey Scott, I want to learn automation, this is it right here. This is the green lettering on a black background. This is our life right here. This is what we do, right? In the Linux world. There are all kinds of other types of automation, but if you want to be like a platform engineer and like a software, not even a software guy, a platform engineer and like a systems engineer supporting your software guys, maybe deploying stuff for them, this is a big part of it right here. I have a fair amount of all this stuff going on. Okay, all right, anyways. So look at all this. There's so much stuff. So can I filter that down? Yeah, I can use this filter module here to look for just the Ansible distribution. So I can get just the Ansible distribution, which is Ubuntu. By the way, I can find this output up here. I can go up. It's alphabetical. So I look for Ansible distribution. I'm in the F's right there. Ansible distribution. There's Ubuntu. I could look for any of these other things. Ansible distribution file parse true. Ansible distribution file path right there. Right? So if I wanted to find that, I would rerun this command here, and I would just drop in that value instead. Control-Shift-V, because you're in a browser, so you have to do weird stuff. And this should find that one path for me right there. When you run setup or gather facts true when we get to playbooks, you can use any one of those variables you want in any way you want to make decisions on your book, on your servers. You can use this this one here to say only if Ansible distribution equals Ubuntu do I install these things. Also, and I get into this much later in these labs, if I want to make a whole block, which is kind of like a function, but a whole block of multiple tasks only occur if something happens, I can do that as well. So I can do it per playbook, per task of the playbook, if you will, or I could do it per block of the playbook and only fall into the block if something's true. So there's different ways to do it. You could do it as a tag, and then all through the playbook, only if that tag is found, do the tag based on the logic. But there's like so many ways to do it. And I'm going to tell you, keep it as simple as you can so that your stuff is usable by other people. If you just go write stuff that's so super specific to one problem, you're never going to reuse it, and that's fine. Just know why you do certain things, okay? All right, so we did that one, and then send this output to a file. So we got to throw it to a file of our root distribution. And then I'm going to say, let's do a filter for time. This is one of my favorite ones to show you guys, because this is all the ways that your system inside of Ansible knows to look at date and time. This is excellent to me. I can use something like this. I use this one right here, ISO 8601 basic short. And we can stamp, this onto a file for a report or some type of printout that we're doing, and we can get that information out to the system. So I'm going to throw that to a file as well, and that'll print out to a file, and then now we've got those two files, and we should be able to hit check. But look at this real quick. In a playbook, and later when we do Jinja templates especially, we can call Ansible _ date _ time dot any one of these things we want, because that's how we reference variables inside of JSON, right? We say Ansible _ date _ time dot whatever thing we want here, dot ISO 8601 basic short, and we call those things and then see them. So if I hit check here, it'll say, look at you learning Ansible. You solved this challenge. So we just did Ansible Lab 3, Ansible and ad hoc, and we filtered down to any one piece of this we wanted to kind of look at. And there's all the commands there for you to do that. Very, very useful to learn how to do ad hoc commands to push things or pull things around. But ad hoc commands are, they're fun, they're fine to use, they're a good way to supplant needing to write, for loops in Bash that loop over a list of servers and stuff, sure. But what they're can you explain using setup module? Using setup. Well, the reason this is ad hoc is this. Let me explain ad hoc to you guys real quick. So, right here, the reason this is called ad hoc is I'm saying Ansible, right here, I'm saying Ansible, please, against servers, run this setup module. And it's going to go do it, right? So hold on. But ad hoc mode means you're just doing one thing. Whereas the mode that we're going to move to contrast against ad hoc is playbook mode. And in playbook mode, we're going to do a gathering of facts at the beginning. And then we're going to call a bunch of tasks. I thought raw shell or ad hoc. No, ad hoc mode is this. Anytime when I call an individual command, ad hoc is kind of like a la carte. This is the difference for me. Let me explain ad hoc versus playbooks for you guys for a second, because those are the two ways you can run Ansible for the most part. The only ways I've ever used. Ad hoc is I'm running one command to see how it works. I could say Ansible-m copy, and then I can say the argument is from here, right? Copy this host file. So copy-m source is equal to, I gotta do equals in here, root hosts, is that right? And then dest is equal to root test or something like that, right? And if I do that, yeah, that'll copy it over. But that's an ad hoc command because that's one command run by itself. So this is the way I think of ad hoc versus playbooks. Real quick, because I haven't used this example in a while, and I know this is silly, guys. I realize what I'm about to say is very silly, but it may help some of this stick with you. Ad hoc is like I walk into a Mexican restaurant. There's a lot of Mexican restaurants in Phoenix. We love our Mexican food. We're very close to the border. It's very, very good Mexican food. I grew up here my whole life with it. Ad hoc is like this. I walk in and I say, I would like a taco, and a taco. And they look at me funny and they go, you want 3 tacos? And I said, yes, I would like a taco, and a taco. And then I sit down and they bring me my 3 tacos. That is ad hoc. Now, somebody might say, well, Scott, did you know that you could just order a number 7? And by the way, that is 3 tacos at Taco Bell, but that's neither here nor there. I'm just using it as an example. Did you know you could order a number 7 and just get 3 tacos? And I go, yeah, I did know that, but I'm still just going to say I want a taco, and a taco. That's ad hoc, or actually in a restaurant, that's called a la carte. It's the same thing here. But what if like me and 7 of my friends came in and I was like, I would like a taco, and a taco. And then my buddy's like, I want a burrito, and a taco. And somebody else is like this. And they're like, no, hold on. You get a number 7, you get a number 3, you get a number 1, go sit down at your table. That is the idea to me of batching things up as a playbook. Ad hoc is you're saying each individual thing. And the other weakness of ad hoc is, do you see how it printed all this to the screen here? This is gone forever. I can rerun this. Watch, I can rerun this and it's idempotent. It's not going to run again. Watch, it's going to say good. So you see how the first time I had to copy and the second time it was good? But now that data are gone forever. The data does not exist anymore. So where I'm going with that is ad hoc is fine, but I can't build on this to then say, okay, if that's been copied over, let's go to the next part of our playbook and let's go to the next part and the next part and the next part. It's like individual states of memory that go away forever. So ad hoc is very useful for like quick testing and prototyping of things, but it has no power in real building of things against hundreds of servers. For that, we need playbooks. But you say, well, Scott, why are you showing us this ad hoc stuff? Well, because I'm showing you how to walk in and order something individually in Ansible, and then we're going to go in and we're going to make it powerful. And you're going to, when you guys start to see, like for some of you guys that maybe have not played with Ansible, when you see a playbook run against a bunch of servers and it breaks on 2 of them, and I go, that's fine. I go fix those 2 servers real quick, and I hit the playbook run again, and it runs against the first 28 servers, and it's just green like this, but it changes on the 2 servers it needs to, you'll immediately go, that's why there's a cult for Ansible. That's why a bunch of sysadmins are like, F all that other, F those bash scripts where we're copying and restarting things all the time, and it only makes changes where it needs to based on the declarative state of the system. Like, you declared what you wanted, and it checked the state and only changed things where you needed to. That is so powerful. It's like, it's like if I were if there were a bunch of cracks in the asphalt and I could just put a glob at the end and just go like this and fix all the cracks, but then there were a couple that had some stuff in them, so I cleaned it out and I just went like this again. It wouldn't fill those other cracks anymore. It would just fix the ones that need it, and that's exactly how Ansible works for us as systems engineers. It's so tremendously powerful for that kind of stuff. All right, so we did our first 3 labs, and that's typically what I do is I just run through labs on Sunday. But to show some of this, and by the way, so the first one is install, the second one was play with the inventory. The next 2 are just running ad hoc commands to see them happen. Then we start to build playbooks. But I'm going to jump us all the way down to the most recent one we built. And that's Ansible to generate a CSV, because I know some of you guys are champing at the bits, right? The proper term is champing, not chomping. People always say chomping at the bit, and that's not an accurate term. They champ at a bit. A horse champs at a bit. You say, what's a bit? It's a thing in the horse's mouth, right? It's not a systems thing. All right, hold on. I need to go to here, grab this. If anybody wants to do this lab with me, this is a newer lab that we set up the other day. It's going to jump forward a little bit in some of your understanding. Some of you are going to have seen this before, but it's still going to walk you through everything. I'm going to pin this one. So if anybody wants to do this lab with me, let's go ahead and do it. In fact, I'm going to give you guys a minute to get in there. I'm going to drop me off of here and say hourglass. We'll start this one in Start Lab in 3 minutes. Start our lab in 3 minutes, all right? Anybody wants to do the lab with us, there it is pinned. It's free. I'm going to go get me some more water. And anybody that wants to, we'll do the lab here in 3 minutes. 3 minutes from right now. All right. Go grab some water. I'll be right back. Grab my water bottles. Got a minute left. Anybody wants to do the lab with me? Hop on. It's on Killer Coda under Het Tanis Ansible Labs. You guys can see it at the top there for, I guess, people on YouTube. You guys are welcome to do these Ansible Labs with us. They are free on Killer Coda. By the way, Sunday morning, we do have a Discord that's out there. You guys are welcome to go hang out in Discord and talk shop with other engineers and architects and all that kind of stuff. And you guys can follow along with that. That's just the Prolog Discord. You can search it with Professional Linux Users Group. It's kind of weird that my my YouTube, I'm not seeing the chat over there, but that's fine. It doesn't really matter. Nice. All right, we're going to start this lab. Anybody that's following along is getting in here and doing it with us. So, what does this lab say to do? This one says management has requested that you provide system information about all the parts of your high-performance compute cluster and give it to them in a format that they can digest via Excel. Yep, Traffic King, I need to start remembering to do that. Like all of these different labs, I need to start putting them into the lab over on the YouTube side so people can find the labs. I definitely need to do that. You've decided to build an Ansible playbook that can report out in a .csv format. Now, if anybody here, hold on, it's almost like I need a show of hands. You know what? Hold on. Let me make a little poll here. Have you seen management use? Yes. No. This. There you go. Have you guys seen management use Excel? Does management, no matter what you can do, and no matter how cool you format the data and do whatever, have you had management ask you, can you just put this out in an Excel format for us? Your options are yes, no, this isn't where I parked my car. Right? Those are your answers. I mean, but honestly, it's like this is what management does. They want stuff out in an Excel format, so we can email it. Yeah, Traffic King, I appreciate that. Anything to help the channel out, I definitely appreciate that. So here we go. We're gonna do the lab, and I say verify that our Etsy or that our root host, so cat root host, that's there, and then I say to create a directory called root playbook roles, and then create one galaxy inside of root playbook roles called data gather. Now this adds some stuff from other labs, and I jumped way far ahead, but I know that some of you have done this, so we're just going to do it. For people that haven't done this before, do it with us, and then go back and review later, because we've got all these other labs for you, right? There's so many labs, right? So cat Etsy host or cat root host, we see them, and in here there's an environment prod and an environment dev, and an app DB and an app web, which are just some variables that we've added to this playbook for those nodes. So there are other things that we can then slice as these servers fall into our playbook, right? So now we're going to make some directories. I'm going to make one called root playbook roles and root playbooks reports. I don't need the -p in both cases, but I'm just going to use it. I used it when we built the lab, just so we have it. Then we're going to cd over into roles, and we're going to make this Ansible galaxy. And I'm going to see that there's nothing there. I did an ls-l, there's nothing there. I did a tree, there's nothing there. Tree is a real useful command when you're first using Linux to show you things in like a structured format. As you get to doing this, you're not going to need it. But tree is really useful when you're first doing it. Now we used Galaxy to build, we init a data_gather playbook, a role that we're going to inherit. So let's go look at that. And we see that now when we did our thing, we've got this one role here for our ls-l, we see a role. And then here's all of the different files and paths underneath there. The ones that we care about are down here in tasks, this main.yaml. And then we also need some template stuff. So we got to do a few things for a playbook to inherit a role. We're going to make this basic playbook here. We'll copy it first, then we'll go look at it. And it is a simple data gather playbook. We jumped from Ansible ad hoc to playbooks, I know that, but this is good. Some of you guys are probably a little more advanced, so you're like, this is good for me. I haven't seen this stuff. But some of you, maybe this is a bit of a jump, but again, we'll go through the rest of the labs. We'll keep working on them. The only thing I know for certain on Sunday is we do labs, right? We're working through stuff, understanding things. Our hosts are going to be servers based out of this. Out of our root hosts, there's our servers inventory. There's our host of control plane and node 01. They are the two servers in that host group. Okay. We don't have any special vars. We have data. Gather facts as true, which means that we're going to do our collection of data like setup. And then become is true, so we would become root through a pseudo methodology if we didn't have it. But it's all there, so it's fine. And then the roles that we're going to inherit, we have no tasks directly in this playbook. This is a different model of playbooks than even the average person that just builds a bunch of tasks. We're now inheriting a role, and we're inheriting the role data gather that we're going to go build right now. So there's, again, a lot of parts moving here. I have a playbook too that just makes you download one that's like an enterprise ready one, and then you just go play with it. And I've been building that as we go too. But anyway, so I come over here and I say, cat this out. Let's copy in the main and look at that one. And here is the actual tasks that we're going to do inside of the role that we inherit. And I said right here, there's just a bunch of comments, because comments are basically free, guys. Use comments all over your stuff if you want. Hey, thanks for the follow, C#. Hopefully this stuff's useful to you. And Jump Scare Love, I missed yours. If you're still around, I appreciate you coming by. I don't know how I missed that one. But yeah, all you guys following, follows are always appreciated. Lurking is the backbone of Twitch, so even if you never talk on here, you guys are still being, super useful, hanging out. So I want to gather a bunch of information, and I wanted to find the server name, the server model, and the server make and the server model. I can get all those from facts inside the system from that fact setup. But there's two things I can't get. I have to get the processor type from doing an LSCPU and cutting it a bunch of ways. And then I need to gather the socket numbers, and I need to do an LSCPU for that as well. But when I do that, I need to register that variable out in a way that I can then see that variable work. So then I debug everything because I want to see all my tasty little variables work. I want to see everything happen and everything that's going on in here. I want to see it all before I go report it out in a CSV format. But to get this to work, I need to add -VV. So verbosity level of 2. So those V's that we were adding at the command line earlier, if I don't add those, this does nothing. If I do add them, this debug will work. So it's kind of a cool little thing where I can leave this in the playbook and I don't have to comment it out before I give it to some junior engineers or my network operations team, because they can run it and they'll never see the debug information. Any of you that have ever coded, you know that we don't debug shit when we hand it out to people for real. We don't just have debug messages flying out to users. That's insane, right? It's the same thing when you hand something off to like another team or like a junior engineer to run when you're out for the weekend. If you leave all your debug messages on, you're gonna have a nightmare. They're gonna be calling you on your weekend or on your vacation. So we leave this in there, but we set the verbosity level to 2, meaning only if you want to see them and know how to see them do I show them. That's super useful, right? That's one of the things that when I learned how to do that, I was like, that's gonna make me better right off as like an engineer and as a guy who does this automation. That's great because I don't need to show you crap, and I can see it whenever I want when I'm testing it. Very useful to just be able to flip a bit and change everything, right? And then when we're done, we're going to deploy it all. We're going to use a full path to this deployer this is the Jinja template of data_gather.j2, and then when we print it out, we're going to add in a variable that I showed you guys earlier, which is the ISO basic 8601 short, and we're going to timestamp our reports as they come out. Now, if we do all that stuff, the last thing we need to do is copy in the playbook that we're calling, or the Jinja template that we're calling, and let's go look at that Jinja template. That Jinja template's the simplest thing ever. I'm going to clear the screen so you guys can see just it. And it doesn't look pretty, and you say, why doesn't it look pretty? Because it's Jinja, and Jinja's a templating format, and your management has constrained you in such a way that you have to report it out. Well, back up. Management told you they want it to be able to look at it in Excel because every manager on planet Earth, well, every manager that's worth their chops, has opened up an Excel and turned something into a pivot table, right? I don't know if any of you have ever seen, like, there's some graph inside of your PowerPoints that your manager's showing you or whatever. I guarantee you some manager up that chain built that in Excel. It's a pivot chart or a pivot table or whatever the hell they call them inside of Excel. They didn't do that in Seaborn or Matplotlib out of a Python playbook. That's not how they got to that, right? I'm not shitting on managers. I've had some brilliant managers. I had a manager once who he walked in and took his RHCE in like the early 2000s without even studying for it. He went past the Red Hat RHCE for like version 4. He was a really good manager. He really knew his shit. But I'm just saying in general, like managers are you know, they're not supposed to be technical. They want to use the productivity tools, and Excel is the one that Excel runs the world, man. People that think that like, oh hey, I'm gonna get real good at data science, I'm gonna do all this stuff, and people are gonna love me. Yeah, and then the next thing they're gonna do after they love you for your cool presentation inside of, you know, you pulled all this data out of Snowflake and you dropped it down into a really cool like a Power BI. The absolute next question you're going to be asked is, can you give that to us in Excel format? Tell me that's not true, and I'll get you 10 engineers in our Discord that do data science all day. That's what they do professionally, and they'll tell you that's what their life is. I can think of at least like 4 of them right now off the top of my head without even like asking for it, right? Yeah, like this is. I mean, this it is what it is, right? It's like it's almost like the Dilbert, right? Like we may hate it, we may say it's silliness, but it's still the way the world works. It's the same thing I tell engineers about learning VI. You have to learn VI, and they're like, I'll use whatever, and I'm like, all right, pull that up in front, pull up whatever that other tool is you want in front of a bunch of engineers and see what happens. I'm not even being mean. I'm just saying, do it and see what happens. All right, so anyway, so we're here. It's a bunch of CSV. It's not pretty. It doesn't have to be because it's going to be printed out as CSV. Down here, we're going to do a loop, and we're going to look for all the play hosts that started, which for us is just control plane and node 01. But in a bigger environment, this could be 1,000 machines. In fact, I just ran one. I wrote this for you guys the other day when I built this lab, because this lab only came out like a few days ago. I had just done the same exact thing at work for 1,195 nodes. I had done the same exact thing right here. Same thing. Management wanted to see this. I added date myself because I thought date would be useful to know when it was pulled. But they wanted to know this about the servers. I think I changed node name. But then down here, we're going to pull, this is our Ansible datetime.date and Ansible datetime.time. So we get a date and a timestamp. Then we get the first value that's going to map to node name. We get the value that's going to map to server make, and we're going to pull all of that information for each of our servers and drop it into this output template here. All right. So if you did all that and you ran it all right, and all you have to do is push the buttons, you come down here and it says now that we have the role in the playbook correct, let's execute it and see it work. So we're going to run this playbook, and we're going to watch this thing gather that data. So it's going to go gather the data. It skipped the debug because I didn't say to be verbose about the debug. I'm going to be verbose here in a second. And then if I ls in here, I'm going to go up 1, and I'm going to cd to reports. If I ls in here, there's my report. And if I more that report real quick, that's it. That's what information came out of this system based on what we just did there. Now this isn't so super pretty, but watch this. I'm going to grab this, all this right here. By the way, there's one logical problem with this, but we're not going to worry about it right now. And that is that there's a comma right here in this, and that's going to, because there's a comma in this output, it's going to push all of our output out one. So I would have to fix this before I formatted this for people, for management. But I still wanted to show you guys real quick. So I'm going to show that. I'm going to paste that. Whoops, I'm going to paste that over here. Whoops. Why did I only do the one? Hold on. Alright, grab that. Come over here. Control A, Control V. Alright, so we've got that, and it's just those 3 lines, and I'm going to hit File, Save As. I'm going to save this in my downloads as an all types of files, and I'm going to call it test.csv. We'll call it test stream.csv. It'll be my most recent thing in my files here. So I go to my downloads. It's the most recent thing. It's the only one right here. And I open it up, and it should be that output that we just wanted there. Now, like I said, because there's a comma in that other output, this is broken by 1. This is moved over to the right 1 space more than it needs to be. And that's because this had a comma in it. So this messed up our output. So we could fix that so that it comes out correctly. And the way we might fix that would be in our playbook execution. If we would, so in our playbook, which is here, right here, we can change this. I'm going to VI this. And on this one here, where we are looking for model name, we can cut on this, and then afterwards we could cut again if we wanted to. Cut dash D on comma, right? And then the field will be 1 for that one. Escape colon WQ. We'll rerun the playbook real quick. This should work. Let's see if it works. That comes out. And our most recent one is this one. So I do more on this one. And now it only shows the first part of it up to the Sandy Bridge and then the comma. So now this one should come out correctly. So I'm going to grab this. Watch. This will be copied. I'm going to paste this in. Right? And this one, if this is right, which it should be, I'm going to hit File and Save. Oh, it's protected because this is open. All right. Look at that broken. See how that's out one? Let's get rid of it. Let's close this. Don't save it. And then no. And then I'm going to save it again because I couldn't save it because it was open in another program. Let's save it. And then let's open it in that program again. Again, this is product. This is manager stuff, guys. I'm showing you manager stuff right now. Now it's lined up correctly. I'm showing you management stuff because no engineer out here gets to not be in manager. Like, you have to interact with a manager. Like, you're an engineer, you're going to interface with the business. If you've got a good manager, they're going to provide you good air cover and just ask for things. They're not going to let the rabid wolves of the rest of the teams and the rest of the managers bug you. But this is, this is how we pull this information down. Now I've pulled that information out, and then my manager can go and turn that into a nice little, whatever those things are called, pivot tables and stuff, right? And look, I'm going to tell you right now, people think I'm joking around about this. Being a Linux engineer is great. Like, I think being a Linux engineer and systems engineer, most people don't even know what you do, so you're basically like a magician to the company, right? Like, nobody even knows what you have to do, so but there's also some danger in that. Like, they'll fire you because they don't know what you do, but or well, not fire you, but like lay you off and stuff. But there's another side to that. There's another side to where I tell people, if you know how to do like Excel really well, and if you know how to do PowerPoint really well, I don't think you're getting let go in most rounds of cuts from a company, because the upper management realizes the value you have in providing visualization through those tools. And I watched all kinds of people get laid off in companies over the years, and even the last 10 years, or the last 2 years rather. I've been telling people, like, it's a good market to keep your skills sharp in. Like, learn another skill and get good at some kind of other systems thing than even what you normally do, because, like, you need to know this stuff. And to that point, like, people that know how to do those productivity things, they do not get let go. Because, man, like, some upper manager knows that you know what you're doing. All right, anyway, so we could cap these all out and look at them. There's my broken one and there's my fixed one. And I did that just to kind of show you guys that it'll look a certain way. Now let's do this where we can see all of the playbook work. This will give us all of those variables that weren't debugging before. Look at all those. I can see all the variables and be like, okay, I understand. That looks good. That looks good. Okay, I don't like that, so I'm going to change it, right? I can just look through the data now and see what the data are going to output as. And then I see here that it's going to write out to, and look, here's some verbosity, so it gives me some other stuff. And it's always going to write a new one. So here's my thing, my new CSV. And if I cat Control-Shift-V in this terminal, it'll print out and it'll show me that CSV. This is ugly as crap at the terminal, guys. But the CSV file that your management asked for wasn't for you. It wasn't for me at the terminal. It's for the thing that they're going to go stuff it in, which is Excel, and turn it into something nice on their end. People want to track things different ways, and I'm just going to tell you, it's a good thing to understand as an engineer how to pump this out, because I don't want to go make this by hand. I don't want to make this by hand across 1,100. I told you guys, I did it the other day against 1,195 nodes. That right there, popped them all out. We found about 40 nodes down, which is pretty standard in a high-performance compute cluster of that size. It's about a little over 3, a little under 4%, I think, of the nodes down. And, yeah, a little over 3%, a little under 4. Yeah, of the nodes down. That's about normal attrition of nodes in a system that big, and we need to clean some of those up and stuff, and some of those have been removed out. So then we could find them and clean the environment up so we get better reports. But the point is, I can pull this data from all the servers that are up. And you might say, well, what about pulling data from servers that are down? I'm going to tell you, don't wait till your servers are down to pull data from them. Because I get asked this all the time, like in the high performance compute world. They're like, hey, yeah, we're managing our and I do, like I think I told you guys, I work for Redline Performance Solutions, and I'm a full-time employee for them, and I'm contracted out to different projects. My primary project is a big college in the Northwest, and then I also do NOAA, which is the National Oceanographic and Atmospheric Agency. I did all their Ansible for their current model of weather for the next 10 years on their HPC. And then I get contracted out to other people. Other people ask me questions and bring me in on projects and stuff. And all of the time, I tell them, like, they'll be like, well, can we get this information off of these 10 nodes that are down right now? And I'm like, fuck, man, if I can't SSH to it, I could go to it in a data center if it's local, but that's about it, right? Like, we want to gather this data while the systems are up, when everything's good, right? And this is a thing that, like, I think admins and engineers are particularly bad at this. You want to check things when it's sunny out. And what do I mean? What the hell do I mean by that? I mean, you should be building your models to check things and test things while everything's good. You do not want to wait until you're, like, in the middle of the night getting called out for an outage of some type to understand how to use your tools, right? It's this idea that I tell people all the time. This is an old military thing. You train like you fight. You have to understand how your tools work. You can't, if you can't do it slow, you can't do it fast, right? It's this idea that know how your pieces of your tools work and understand how to monitor your stuff before shit hits the fan. And if you have things already there, I can give you all this information about all these servers, even if half our servers go down. Somebody's like, oh shoot, man, do you think there's some correlation between the few hundred nodes that are down and some other thing? I can't see anything. And I go, well, you know, the names are pretty similar, so they're the same generation of drop into our high performance compute system, because high performance compute systems tend to have different hardware models over time. It's a new version of this and this, and oh, by the way, they're all connected to those same 10 HDR switches inside of the back end for the InfiniBand or something. That's something that's similar across all of them. But how would you know that? Like, I tell you guys all the time, how would you know anything? If I told you right here that this system had 1,100 systems behind it, like if I said, hey, you're on control plane and that's your jump box for 1,100 other systems, how is anybody here going to tell me I'm not telling you the truth? I mean, we could try. That would maybe start us out, but the point is, you don't. And even if you came in and you knew there was 1,200 systems there, or 1,100 and something, and even if you could get into all of them, I mean, you have to know how to use your tools. And don't think like in the middle of the night you're going to get some superpowers to go do it. You need to know how to do it already. So this is why I show you guys this kind of stuff and tell you guys why this is so important. All right, I can see these ones. I can see the new ones fixed. I can see that it kept making new ones with the new timestamp on it, so that's awesome. There's no overwriting of any of the old stuff. And I hit check, and it says, look at you learning Ansible. You created a role that pulled information and reported out in a .csv format to keep the management fed full of tasty information. That's what your management wanted to see, right? It's what the people want. And then you cannot have to do this when management asks you stuff. Because management's going to ask you all kind. I mean, anybody here that's worked in tech knows that management comes at you with the most off-the-wall stuff that you're like, why would you need to know that? But they need to know it. And you need to be the one to provide it in a lot of cases, because you're the one that knows the system. And again, I tell you guys this, nobody in your company knows what the Linux engineers do and the platform engineers and stuff. They just think that you do magic like over a cauldron and stuff works. So doing this stuff and being able to break it down and feed that out, because by the way, now we could just feed this out and like either let somebody push a button and run it with like Tower or something, or we could put this on a cron job and just send it to them in an email. Or we can send it to Teams. Super easy to do that kind of stuff. You just have to go build those things, right? You just have to have a place to output it to. All right. And by the way, we have, let me think if I have any labs to do that. We don't have anything like that in the Killer Coda, because in the Killer Coda, this is generally available to anybody. But I do have labs down in our in our Discord, so people that join our Discord, I do have labs down in there where you can send stuff to our Discord in the sandbox. So if you were like, hey, I do want to learn how to do that, you can go look around in there. You can ask me down in there, and I'll show you where that stuff is. But we also write stuff out like from Grafana and different monitoring tools, so we can automatically alert out to our sandbox as well. And the one that I was showing earlier was actually whenever my main jump box boots, anywhere that I am, because I travel around, anywhere that I am, if my main home jump box reboots for any reason, it alerts me through Discord. It alerts out to my Discord. When it comes back up, it alerts out to my Discord. And if I'm anywhere, it alerts me in my sandbox and Discord that something's changed. Like the main thing that I care about, which is my DMZ jump box that I can hit anywhere in the world. I want to know if that box went down. I want to know because normally that's the first thing we do before we compromise the system. If we can kick a box over and get it on its boot up, especially when we're physically at it, that's it. It's game over if you can get a box to boot and you're at the box. Always. There's no other compromise needed at that point. There's very few devices over the years. There was one in Trusted Solaris that you couldn't get access to at the single single run level. So run level 1 is single user mode. The only one I've ever seen is Trusted Solaris, and you had to have a physical hardware key that you turned on the device, and then you could get into single user mode. Every other Linux box out there, every other modern Linux operating system is compromised once it comes up and you're at a console. Now, I'm not saying you're in over SSH. I'm saying if you're sitting at a console when the box boots, you've compromised the box, right? Okay. But we're not doing security right now, but if anybody wants to talk security, let me know, and we'll make that one of our topics. All right. What are we doing? We're doing more labs. Sunday is always for labs, guys. So I'm going to jump back a second. And somebody asked me this one earlier, so I'm going to do this one because I think this is a good one. It's kind of in between the early ones that we were doing that were simple and the really more advanced one that we just did. But I think that this one's still very valuable for you guys. I do have some Terraform labs. They're not in here with the Ansible ones. They're over here. The Terraform labs I'll link to you. They're over in our HashiCorp labs. And there's some basic ones installing Terraform and then doing some container deployments. But I don't have any major Terraform ones. In fact, it's funny. I got my Terraform cert 2 years ago, and it's going to lapse at the end of this month. And it's because I'm not doing Terraform anymore, neither professionally nor for fun, because they changed some stuff with their business source license. You guys can look at that if you want. You can go look that up if you guys are interested in that. But that's why I and a lot of organizations are no longer using HashiCorp. It happened in August of this year, and you can go read about it if you want. All right, so this lab is going to be about pushing facts to all of my servers so that my servers, remember I always talk about my servers like a bunch of, like a Plinko machine at the start of a playbook, and then my servers are going to get filtered out into different groups as they go. This is very, very, very powerful. This is a very powerful way to run Ansible so that it does not matter what the business gives me. I'm ready based on how I stamped my servers to be known according to the business. So like you've got like a configuration management database, CMDB. Configuration management database is run by your CM team, your configuration management team, depending on the size of your organization. They are typically outside of the systems engineering teams, and they make sure that there's changes that are put in before people make changes in the system. They are a valuable tool for stability in the system. What they end up being, though, that's the technical what they are. What they actually are to us systems engineer tends to be a roadblock for stuff that we want to do in our environment, which is fine. I tell people all the time, you can sit here and you can muscle up and be like, I'm going to fight everybody and we're going to have a... Or you can learn how to ride over the top and have yourself a lot less problems. I tell people all the time, like, if you've ever watched somebody surf, do you think the guy that's up surfing on top of the wave is having a better time than the guy that's tumbling down inside of the wave? Probably the guy on top. So I tell people I learned the process management well enough to just ride over the top because I think that makes my life easier. My point in that is your CMDB, your configuration management database, is going to have tagged, typically if it's a good one, your servers for different environments and different things, and Hopefully your team has been putting stuff in there, and different development teams that are maybe like your devs, your computer sciencey type people that are building stuff and asking you to build servers and stuff for them, and maybe even using automated processes that you've used to build servers for them. They should be tagging servers certain ways so that the CMDB is updated. Should always be your source of truth, but they're always messed up in systems. Um, and what I like to do is I take the information out of the CMDB and I stamp that to my servers. So now, if the CMDB changes every day, I'll stamp these to my servers. So then at night, when you give me from the content management database, you tell me, hey, the change is in. There have been 50 servers approved to be patched this patch night. Those just get fed into the top of my low Plinko machine, and my servers, they all go the different routes they need to in my playbook to patch properly. Okay, so let's look at how this is a way to do what I just described. Again, I like to focus on the how things are done, and then I'm explaining to you the why. But let's verify our root host file, cat root hosts. And then I say verify, what the heck happened to this? Oh, we got to verify these other ones. There's another one here called custom fact push. And okay, that's a playbook. And then we have a custom one called group by YAML. All right, so let's go up here. Let's look at what these playbooks are doing. This playbook is a simple playbook. There's no inherited roles here. Nothing getting inherited. It's calling against the host servers. So it's going to feed these two servers in, control plane and node 01. Good, got that. At the beginning, I'm going to debug any environmental variables I have just to see them. Well, I happen to have environmental variables that I've tagged to these called prod and dev. So I'm going to get a report from each of those servers that one of them has the environment variable prod tagged to it and the other one has dev tagged to it. These are hard-coded in the inventory, and maybe that's the way that your organization does it. Not all organizations are going to do that. That's fine. Down here, I say to go to each of those servers. So this is a playbook. This is a task called file in that playbook. And I'm going to go write etc ansible facts.d as a directory on both of those two servers. Does not matter. I'm not doing any condition. It's just going to do it on both of those servers. Then I'm going to push over a file that I have locally called root prod underscore patching.fact. And I'm going to put that to the prod server as patching.fact, the prod one. And then I'm going to go to the dev server and push the dev one, but both of them are going to get stamped to the server as patching.fact, regardless of what they started as, prod or dev. They're going to get named the same thing when they get stamped over there. That's what these two copy modules do, right? And then we come down here, and now we're going to do a group by thing. So let's look at those real quick. Let's look at those. Let's ls. And I'm going to cap my dev patching, and I'm going to cap my prod patching.fact. So these are the two things that are going to get stamped onto those servers according to these two copy modules that are called right here. So let's see what facts are going to be put on my servers. Servers that have the dev patching fact, which again, when it gets stamped over there, just becomes patching.fact. And when this one gets stamped over there, it just becomes patching.fact, but only on the right server. Patch group is group 1. Patch group is group 2. Okay? That is going to be then, we're going to do an inventory thing here, and we're going to split those into different host groups. Rebooting is true for my prod environment, and rebooting is false for my dev environment. So now I can use that rebooting variable that I'm pulling off of a server. Again, when I do the playbook in the middle of the night, my servers can know information about whether they're allowed to patch or not based on the information that I pulled for them out of this, right? And I set this information out of data that, again, I just made these here, but in a real environment, I would pull this information out of like my content management database, which tends to be like ServiceNow or Sharewell, or what are some other ones? You can get information for a content management database out of AWS if you want. You can just pull information down from them. You can pull it from an API if you have some other API out there of just what your inventory is. If I know that it's an app server true, database false, web server false, app server true, false, false. So these ones that I was doing, I assumed that both of these servers happened to be app servers. But if they weren't app servers, they may have been a web server, and our web servers maybe have to be rolled through in the playbook based on the fact that I have to have 3 of my 10 web servers up or something like that, right? Because I have a load balancer pointing at 10 back-end servers or something. So there's all this stuff that we could do, but again, we have to do it's like we have to do this simple thing before we can think about those things. But I'm trying to tell you those things because that's the reason this is important. It's important to be able to grab information and stamp it. And I had a good engineer years ago tell me, Scott, I only need to make something work once. Once I can make it work once, I can modify it in all the different ways I want. I was like that. So now here's our playbook that's going to be called root. So it's in root. It's group underscore by. It's going to go get our servers. And the first thing it's going to do is it's going to show us all the groups that are in the playbook. Then we're going to group our servers, any servers that come into this playbook, we're going to group them by Ansible underscore local dot patching dot patch group, which is going to point to this group 1 or group 2, and we're going to make those patch groups automatically in the playbook as it's going, and we're going to group those servers by it. Then we're going to check rebooting, and if rebooting is true, then we're going to put them in the Ansible local patching rebooting group. We're going to set that fact to true on that server. So actually, we're not even setting fact. We're just grouping those servers by the key rebooting. So some servers are going to be rebooting, some servers are not. When there's true, right here in this rebooting variable, or fact, as you want to call it, right? And then at the end, we're going to show the groups. So you're going to see all the groups at the start. We're going to do 2 grouping things, and then you're going to see the groups at the end. That's what we're doing here, right? So we come down here and let's just run it. So we cat root hosts, boom. Cat the custom fact, cat the root by. We did all that. Now let's just run it. Let's see what happens. Run it. It's going to push it to both servers. Push all those things that I said, and it's only going to push to the node that it's supposed to. And then now let's do the grouping thing. So now we've pushed those fact files onto those servers. And again, I could stamp these every day. I can pull information out of my CMDB. These things tend not to change. Like if a server is an app server, a web server, a dev server, will probably never change in the life of that server. But if it's in patch group 1 or patch group 1.1 or patch group 1.1b, depending on whatever the hell your guys want to do, you can take that every time that changes in that content management database, stamp it over here, and your servers are kind of like I was talking about earlier. They're like a little kid walking with his little lunchbox, and he's got like a little QR on the side of his lunchbox, so we can read what he's bringing and move him into all the kids with chocolate milk sit over here, all the kids with apple juice sit over here, all the kids that brought an extra cookie can go sit over here. We can group our servers based on whatever comes. I mean, I don't know what kids are going to bring to lunch that day, but I could check and move them into the right things. I don't care how you want to think of your servers, right? Your servers are kind of like your little kids because they're just wandering all over the place. Or if you guys have ever heard the term herding cats, right? Trying to get a bunch of cats herded together, not happening, right? The only way to do that is to make the room smaller over time. It's the only way to get cats, because they're going to go everywhere. Cats are like a stable diffusion in a room, right? Like things are going to... All right, anyway, it doesn't matter. Root, let's just run it. Here's the initial groups that are there, and then here's the groups at the end. So let's go look. When we started, there was this group called servers. That was the only group that was there. And then we set the node group for a reboot group. We set the reboot flag on the servers that needed those. And then when we were done, we had these groups. Rebooting was a group. There was a group 2, and there was servers. And these were the ones that were seen by control plane. These were the ones that it's in. And then node 01, he's in group 1 and servers. Let's see if that's right. If I cat root hosts, should group 1, and if I cat dev patching fact and cat prod patching fact, right? Does that line up with what I see? So the prod server is control plane. So control plane sees he is rebooting. He's in group 2 and servers. So he is prod. He's group 2. He is rebooting, and servers is what he was already in because that's what group he started out in. The dev is node 01, and they see that they're in group 1 for dev and servers. So group 1 for dev, and they were already in servers. But they're not in rebooting because they're not rebooting. So that's a proof that all of our things just worked for us right there. So your job, if you say, hey, Scott, I want to do this stuff and I want to be a better admin and an engineer and I want to understand how to maintain my stuff and run these automation tools, this looks really complex at first. I get that. And it looks like a lot of work at first. It kind of is, because you got to get this. But once you wrangle this and you're just like that guy riding on top of the wave, now you're not getting churned up by every time your CMDB changes and every time your management says. One of the biggest problems, this used to happen to us all the time at AAA before I did this. I implemented this process to make this easier. What used to happen was we would have our patch lists all pulled out, and we were going to patch them, but we were using Bash back then, right? Shell, so we were like running shell scripts to patch. And somebody would come in and go, hey, can I just get this P01 APL, whatever, and this P01 BDL, whatever, and can I get these servers pulled out? And somebody on our team would invariably say yes, and they would change it on their version, and they would kick it out and run it. And then one of us would come through later and be like, why didn't these 3 servers patch? Because we didn't get that message. And we would... The miscommunication, the problems, all these other things, you can avoid them all. You tell them, you know what? Make sure it's in your system. I'm going to run a clean version of this, and I'm only going to have the servers I'm supposed to patch. I'm going to check those in when I check in the change to like our dashboard for changes or whatever, and I'm going to give you a list of those servers. You know what? Your CMDB people, you can go look at it all by eye. I'm not going to look at it by eye. I'm going to use your system to pull it. I refuse. If you tell me I got to go look through 1,100 servers by, like, with my eyeballs, with my terrible freaking eyeballs, before I'm not going to do it. I'm going to tell you no. There's a list. You can give me a list, and I can verify it, or I can pull the list from your system. But I'm not, and that's not even being difficult, that's being practical. Because I'm telling you, I've watched it too many times where somebody fat fingers one of these and pulls the server out, and we reboot a production system because somebody asked somebody to change something in the middle of the night. No, we're not going to, you are so error prone in the middle of the night. If you don't think you're error prone in the middle of the night, go drink as many cups of coffee as you want and stay up for like 24 hours. And then try to do some sysadmin work. It's almost like you should just do sysadmin work drunk at that point, if we're being honest, right? It's the same number of errors. You're going to get errors all over the place. So this is the idea in automation of like moving people away from the system. Let the process bake. Let it cook, right? Let the system cook, and we will move away from it. All right. I'm getting too riled up and stuff. This is supposed to be Sunday. Sunday's lab day. Sunday's fun day, right? So we did that lab. So what labs are we doing here? Hey, Colchis. We've done the Ansible intro, which we installed it. We've done the host file. We did the ad hoc command for shell and setup. Then we jumped down here and we reported out CSV because the management goblins need their tasty snacks. Then we came up here because somebody asked me about pushing facts to servers and automating deployments of groups and stuff like that. And that is a way to do it. It's not the only way. It's the way that I designed and ran at a few different big places with thousands of nodes, and it's worked for me. That's the way that I do it, right there. All right, let's do a fun one. This one's fun. We'll do 11, which is message of the day push. This will be playbooks, it'll be modules, and it'll be some fun stuff. So I'm gonna go grab and pin this one. Looks like our other pin's gone away. Pin, whoops, not pin. Hold on. Pin that lab. And here is manually unpinned, so I'll leave this up there while we talk through this stuff. If you guys want to do this lab with me, you can. It's completely free, right? Like I don't get anything for these labs. I maintain them for our community, for the professional Linux users group, and really for anybody that wants to go do these. If the only thing you got out of this stream, if you popped in here for even a second, or like, I can't stand this guy for another second, that's fine. If you went to Killer Coda and just bookmarked this site and started using it to go learn Kubernetes or whatever, that would be the most valuable thing you probably do all day. Maybe all week for most people. It just is what it is. So let's go in here. Not everybody's going to love my labs. That's fine. I don't, it doesn't hurt my feelings. I don't go to sleep at night and say, man, that one person didn't like the labs. It's not for everybody, guys. But I can tell you this. Getting better at command line requires doing command line. I can't think of any other way. Like, I could draw you pictures, I could do PowerPoints and stuff, but I don't think anything will make you understand this better than pushing the button and typing it out and doing it. I really don't. So that's from 20 years of doing it and 15 years of teaching it to 5,000 college students now that I've had. So, all right, verify our root host file. So cat root hosts. Okay, we've got 2 servers. Let's cat root motd push. And this thing is going to push over two different environmental variables. So it's going to debug all the environmental variables to see that env prod and env dev exist on those things. Perfect. We'll debug those out. The servers will tell us what their value is, what their environment variable is, rather. And then, if the server has prod in env, which means this one, that one's going to get this root prod motd pushed over into etc motd. So it's going to go from prod underscore motd to etc motd. So it'll be the message of the day. If it's a dev one, it'll take root dev motd and push that over into dev, into etc motd on that server for there. And then Traffic King asked, he's asking over on YouTube, question, when creating a playbook, what framework do you use to make sure it does what it's supposed to do? Meaning, do you have a template or system architecting playbook for any given task? Traffic King, I don't keep those, but you can find a lot of them. I just kind of have what I've been building, and this is in my GitHub. Oops. GitHub. I was trying to do an exclamation mark. I'm adding this HPC deploy, and this is gonna be just something that you pull down in the Enterprise Sandbox. So one of our playbooks here is called Enterprise Sandbox, and all you do is pull this one down and go play with it. So it's just a bunch of NFS system stuff. It's got the README in there. It's got the host file. The host file is just these basic host file, just these basic things here. And then here's the system YAML, and it shows you how to inherit roles based on the type and stuff. So it starts getting more and more advanced. But this is where I'm going to start putting a lot of that stuff for you. But really, Traffic King, the main thing you need to do is just think out like the steps of what you want to do, and then start to do those individual tasks. And I like to do them against test environment first, make sure that they work properly, and then I go kick them off on all the servers that I need to. But no, like if you're just saying like, do I have like a basic template like this stuff that I start with? No, I just go grab my most recent one and copy it. I cheat all the time and just grab this. This is the start of a YAML file right here. You can put the 3 dashes at the top or not. It doesn't really matter. All right. Anyways, so push the message of the day messages to all servers based on that. All right. So we cat root hosts. See that? We cat the root message of the day push, and we see those things, and then we just run it. Let's run it and see what happens. Right? One test is worth 1,000 expert opinion, guys. Let's see it happen. Yeah, but Traffic King, I don't keep like a library of these. I write them as I go. But I do steal from myself all the time. All the time do I steal from myself. And that's actually one of the things I'm going to do in that enterprise one. I'm just going to keep adding stuff to it so that people can take it and use whatever they need. And the one thing I have in there right now is like a full NFS deploy. Like how do you deploy NFS to a environment or whatever. So on this one, we see that it pushed over to one node and changed, but it didn't push over to the other one. So it skipped the node that didn't meet the condition of the task, right? Both of the tasks had a condition. If prod was in env, it was going to do one thing. So this only pushed over to the prod one, which was control plane, and this one only pushed over to the dev one. So now we can check both of those servers real quick and see if they have the dev or the prod message of the day on them. That's by manually checking them. But if we just want to go hit the server, let's just go see. Let's just SSH over to node 01 and see if it shows us the message of the day. And then let's SSH over to control plane, and that should show us its message of the day. Oh, that's going to reset the terminal, but that should come back up. If you leave your connection, you've left the server, but it should refresh and come back up. But that's the whole playbook right there. Can we see that dev and prod have been stamped? And why might you want to do that? Well, as a systems engineer, it's a very useful thing to make sure that people know when they're on a dev node and they know when they're on a prod node. Now, should that supplant any like system rails or protections you have in place? Absolutely effing not. In a dev environment, you should have your controls so that people can't reboot servers that aren't supposed to. And in a prod environment, you should have those controls. But this is just one more thing to visually stick in somebody's face to say, hey, you're on a prod effing server. That means prod in the enterprise means customers are on it. If this changes in any way and affects their performance and their custom, our customers' ability, you are going to cost the company money. That's what prod means. And if people know that and they still make a change here and they still bring a prod system down, they will be fired. And most importantly, they should be fired because they didn't respect this simple thing, which is if you're in prod, don't affect prod without a proper change. Change takes the risk off. If I make a change in prod, let me explain something as an engineer real quick. If I make a change in a prod environment without a proper change, I assume all the risk. Why the hell would I do that? I don't assume the risk for anything else in the business. I'm not the guy making decisions. I don't hire the next person on the team. My manager does. I may recommend who we should hire and I may sit in on the interviews, but I don't specifically hire people. Does that kind of make sense? Where I'm going with that is, why would I take the risk on myself of fixing something? Why wouldn't I instead just toss something up to management, let them make the decision? And I'll say, guys, look, this is a major problem. This needs to get fixed now as an emergency change. This is a problem. And then management can go and say, hey, change management, I don't want to make this an emergency change. Can we do it Friday night or can we do it Saturday night in our change window? And now hold on. Who took on the risk there? Me, who said it and told the truth, right? Because I always told you guys, like, engineering is the search for truth. Am I the one that's doing it and taking the risk, or is management now taking the risk? Still, the risk is on me because I still have to fix it if it goes down. But the problem is, the point is, it's not my job on the line anymore. Now it's up the chain. I have reported it up. I have given them 2 things to choose from, and they are going to choose from them. Does that kind of make sense? It's also the idea that, like, I don't have to sit around. I watch engineers absolutely, like my hair's all turning white everywhere because I'm getting old. But I watch people, like, literally, like, grit their teeth and fucking shake in meetings. I'm trying to swear too much, but I watch people, like, shake in meetings because they are so mad about something. I'm like, just tell them. Tell the management. Let them worry about it. Let them do it, and you go to sleep just fine tonight. It's like that. It's like that scene in Good Will Hunting where he tells them, he's like, I thought about this thing, and then I never thought about you again. Because what had happened was the main character, Will, he had gotten under the therapist's skin really good. He had talked some shit about his wife in this picture he saw, and his wife had died of cancer, and it really got to Robin Williams. But then he goes, you know what? I realized you could tell me all about this stuff, but you had never done it. Anyways, that's neither here nor there. But my point is, I can tell you, and then I can just go to sleep because I don't have to worry about it anymore. It's not on me. I told you. Now, management now has that, and again, it's probably going to come down that you're going to be rushed to do it on a Saturday night, and that's its own problem. But the point is, like, if I take the risk on of myself of fixing it and I just break stuff in the middle of the day, that's on me, and it probably cost me my job. I've never done that, but I'm telling you, I've watched that happen so many times. I'm like, oh God, here we go again. This guy's just white knuckling and he's pissed and he's flipping out in meetings, and one of these days some dumb mistake's going to happen that could have just been management's mistake to make. All right, it doesn't matter. This happens all the time, though. This is the frustration of engineers. Like, the guy, if you ever see in the movies the guy who's running around with all of the like the papers and the charts and the graphs of, like, all this bad stuff happening, the calamity coming, and you're like, well, I know one thing for certain looking at that guy. He's definitely about to be ignored. And that's, that's how most engineers feel. But the point is, don't like take the risk on yourself. And Sean, put the risk on them. Let them do the decision. He mentioned that over on the YouTube side. He said, always put the risk back on the team. I put the risk back on the government. If I find something in a government system that I've been contracted to do you think I'm going to risk my job and my company's contract to just fix stuff and possibly take down a system? No. I'm gonna alert the proper channels. I'm gonna do a write-up. I love doing write-ups. Like, engineers, we love, if we love any one thing, it's being pedantic, right? It's like writing up the technical reason why something is incorrect, and then sending it off. Let them chew it up. I try to do like a nice little summary at the top because a lot of times people don't know what's going on. So I say, here's the problem, here's the description, here's what I think we should do, and here's like the timeline. And then I give a bunch of technical stuff because I tell you guys, I like to say things and then prove those things true. All right, so we've done labs. We've done labs for 2 hours now. We always do labs on Sundays. Let's do real quick. I'm going to jump over. I'll do something. I don't normally do this on Sundays, but I'm going to jump over and do, we'll do a little presentation here. I don't normally do my presentations on Sundays, but I think 2 hours of labs is pretty good for most people. And let me pop this down. And I will pull up. We'll just talk soft engineering skills real quick. So this is from one of our prologue type things. We'll talk soft engineering skills. and soft engineering says, here we go. And I apologize that this one's a little bright. And I tell you guys all the time, I don't care if you know what my name is. I'm a real person. You can look me up online, right? Soft engineering skills, or what I call day in the life, diddle, day in the life of an engineer. All right. So this is one that I like to show you guys. I need to update this one too. I say that every time I pull it up, but then I forget to update it. Let's look at this real quick and see if we can talk through some of the things that they don't necessarily talk about in college, but you need to know as an engineer, right? So these are things that I show my college students, and then I say these are things you don't learn in college, but then they learned them in college. So I've created I wouldn't call that what is that? I've created a paradox, haven't I? Because they're things you don't learn in college, but I taught them to my students in college. So let's see. Sean said our dev environment just requires that you let others know and teach. Yeah, that's how a lot of dev environments are. Your dev environment should never be so critical that you can't take it down if you need to, right? But dev environments also, we think about them, we sometimes have to ensure that, we let somebody know, like you mentioned, because sometimes you have like 30 engineers in an environment. You don't just want to take it down, right? So we do have to let somebody know and get some soft approval. I call them like soft approvals or soft handoffs, but that's a good one there. In fact, I probably want to add that to this. How we do dev environment work versus prod. That would be a good one, actually. Yeah, and yeah, something critical could be, I saw one time where people took down a dev environment, and they were like, hey, it's just a dev environment. Why does it matter if we took it down? But we had 60 people in a training class, 60 of our so this was at AAA, and it was like they were training agents, and they were having this agents go into the dev environment and looking at like test, like kind of scrubbed out data of like former calls and stuff, and that environment was down because somebody was patching it. And it's like, you guys can't be patching this stuff in the middle of us training 60 brand new engineer, or not even brand new engineers, sorry, brand new like customer service reps on it, and it costs a lot of downtime. But it's like, our dev patching had always been done on like the third Thursday of a month, so somebody should have known, but nobody did know, and it caused this big conflict. But it's one of these things where, again, communication almost always rides. So I'm going to talk about some different things that if you want to get into engineering, these are things that are soft skills. And when I say soft skills, I mean all the other stuff we did, right? All this stuff here was like, go put this code into this thing and it will come out with this output. This is the stuff I prefer doing, because this is the stuff I'm somewhat good at, right? I can make a system do whatever I want it to do if I follow these rules. This stuff is stuff that people don't necessarily tell you, but I think this will make your life easier. This will make you that guy. I should put a little thing here with a guy surfing on top of a wave and a guy tumbling down under the wave. I assure you, the guy tumbling down under the wave is not having a good time. It's the guy that's riding the wave that understands how to interface with the business that's going to help him. So these are my topics here. All right, and then I have more things I need to update. But anyway, so hold on. Let me fix these while we're here. I'm going to add fit for use in updating dev and prod in environments. Right? So this one will be yellow. And then the other one that I need to do is, what was I just talking about? Oh yeah, add in the, add in the surfers. I'm gonna put that. So then I remember, because I don't always come back and edit these, and this one down here, the meeting activities to avoid and call them out. I legitimately probably put this in here like 8 months ago to fix, and I haven't fixed it yet. So I'm gonna leave this one open and do that. But anyway, so let's talk about stand-up meetings. This is something that pretty much all engineering teams on planet Earth do in some way or another, some way, shape, or form. Stand-up meetings used to be when we would meet together, right? And everything's been changed since 2020, but before 2020 and like the time before time, we used to all get together in office buildings, guys, and we used to do engineering and sit there and talk to our buddies and then walk over to like different cubicles and bug each other and then be like, oh, it's lunchtime, and then we'd all go to lunch and then we'd come back, right? Because lunch is a great way to decompress. I used to tell people, I'll go to lunch with you, but if you're talking work, I'm not going lunch with you anymore. Like, lunch for me was always, I'm not talking shop. And so, I mean, look, there's there's talking about what's going on in the shop, and there's talking about work. I am not talking about work when I'm off. Like if I have a 9-hour work day as an engineer, because 1 hour of those is me taking a lunch, and I don't get paid for lunch because engineers never get paid for lunch really. If I have a 9-hour work day because of that, I'm not talking shop during that. Oh, I'll talk about like, you know, what's going on, or oh, I got this new thing I need you to see when we get back, and oh, I was doing this new technique. I'll talk about that stuff. But what I'm saying is like, if you like, hey, let's just do this like a working meeting. I'm like, come on guys, let's fucking chill for a little bit, because we're gonna have all the rest of the day to do that stuff. That's one thing. Another thing I don't always talk about here is engineers. As long as you don't miss your first meeting of the day, engineers show up whenever they want. I tell people all the time, and people think I'm lying about this, I have not been late to work for the last 20 years. Not because I haven't rolled out of bed late, it's just because an engineer's like a wizard. We show up exactly when we intend to. And as long as our work's done, no manager should ever give you shit about that. And now if you're in an organization that does it different, I'd make sure that that's a thing. But I can tell you that was 100% true at Lockheed Martin. That was 100% true for me at CGI, which is a really big company that does government contracts and stuff. That's been true for me at Redline, at all my colleges. That's a little different for me as a college professor, because as a college professor, I have to be there at the right time. But I'm just saying, like, as an engineer, you're not late. You just get your work done for the most part. But you got to get to these meetings, and stand-up meetings should be three things. You should, one, well, this is a thing before the three things. You should make people stand up in stand-up meetings. If we're all physically in the room, make the guy stand up. Because guess what? That person that loves to talk for 45 minutes, and I am not that guy. You guys might think from this that I like to talk. I do not like to talk in meetings. I barely ever talk in meetings. Anybody that's worked with me, and I have a few guys that pop on here that have worked with me professionally, they can tell you, me talking on a meeting is one of the most rare things you'll ever fucking hear. Oh, I'll send you emails all day and I'll type in the meeting, but I don't talk on meetings much because I don't fight about things. I'm not going to die on those hills. I don't care. But anyways, there's three things that they should do. You should make them stand up. What did they accomplish yesterday? What are they working on today? And what blockers do they have? What you accomplished yesterday is what were you doing for the last 8 hours? What are you working on today? If that needs to be realigned by your scrum master or your manager or your PM who might be in here, they can align you for the next 8 hours at the right thing. I thought the most important thing was getting this patching done for this Saturday, but you as a business thinks the most important thing is actually me developing this little widget so that users can push a button and add these two other things to servers that we're building. And I'm like, I didn't realize that was that big of a deal. And management's like, oh yeah, we got a demo in 2 days. I'm like, okay, that's the big deal, and that's what I work on. This is why we do these meetings. If your management just makes you do this every day but nobody ever does anything, you might as well stop doing it. But I'm telling you, this is why we do them. And then this one, this is my favorite one, because this will separate good management from poor management. And Inspector's been dealing with bad management, so I know. But if I tell a meeting as an engineer, like, and engineers get paid a lot of money, guys. Like, I'm not trying to be like a chat about that. I'm just telling you, like, my companies pay me a lot of money, especially my contract jobs. They pay me a lot of money, not just to me, but to like my employer. If I tell a blocker, if I just speak a blocker out into this meeting, again, there's no reason to be in the meeting if people aren't going to fucking do something about it. If I speak a blocker that I have, somebody's not getting back to me, I've pinged them 3 times. Management should take that immediately as an action that they have to do to go get that thing unblocked. Because what am I going to do? Go have a fist fight with the guy to get the information out of him? No, like, when I was younger, I might have fought the guy. But or when I was in the army, we'd have had a fight. But when we're young, like now, what am I going to do? Go get in a fist fight in the office because somebody won't give me information or respond to me on Teams? No, fuck him. His management can find out about it. And it's, again, you're not trying to be confrontational. You're just saying, like, this is a blocker I have. This isn't getting resolved. You guys go deal with it. And good management will go do that for you. Your job as an engineer isn't to go and resolve conflict in an organization and to sing kumbaya and talk about your feelings. That's management's job. Your job as an engineer is to get to the right answer, right? All right, don't let your dreams be mean. Put your BJJ trainer away. Yeah, Inspector, I'll get in trouble if I do that kind of stuff. Oh, you used to hold a medicine ball? That's pretty good, Inspector. I always like to stand up because now everybody's looking at you, and like some guy will be in there and he'll have crumbs on his shirt and stuff. He'll be feeling all embarrassed. But when he was on a Teams call, he loved to talk for 45 minutes. People change completely when you're like sitting in a meeting looking at each other. All right, then this one bugs me more than anything. Every organization on planet Earth, like not all of them, but a lot of them, they're all going agile. Agile will be the thing for 10 years. been the thing for the last, I don't know, 8 or so, and it's probably going to be the thing for a total of about 10 years. And then what's going to happen is management's going to grab onto something else. In fact, I'm already watching them turn it into Safe Agile. In all kinds of organizations, it's going Safe Agile. But what it is they're going to say, we're going to do this methodology, and then they'll immediately not do the 4 tenets. There are 4 tenets of agility in a system. Individuals and interactions over processes and tools, working software over comprehensive documentation, collaboration over contract negotiation, and responding to change over following a plan. That is not what management's used to doing. Management is used to hammering out a contract, even within your company, between your 4 teams on how things are going to happen, and then holding rigidly to that thing in a way that does not change. That is the exact opposite of what agile methodology is. If I find a problem, and me and another engineer, so me and like a guy on the automation team, and I'm over here on Linux team, platform engineering, we find a problem, he and I will very quickly, he or she and I, will very quickly figure out a problem, fix to it, implement a test to that, and by the next meeting, have the test ready, and when we present it, we're like, guys, we're all ready to flip this over, we need to go this way. The way we were going to do it, so I do everything in Ansible, right? The way I was going to do it, everything in Ansible doesn't work with VRO over here. VRO is the vRealize orchestrator for VMware, right? ESXi and stuff. I can't just run my Ansible playbooks directly out of that. The interaction between that didn't work. Now they have an API, so it's easier. But back then, we used to have to call it over, and I had to write all the stuff over here in VRO in JavaScript, right? And we figured this out very quickly. This is actually a real thing that happened. We figured this out very quickly, and we said, all right, I'll write all my stuff in JavaScript to kick off and do my Ansible and get the logic back and show that it's good. But we need to let me focus on this for the next week to get it good across the whole organization. And me and this one engineer, we got that all working, and then that's a whole different concept. It took them like 3 months to approve for me to put it in, but we had it fixed immediately in our operating area, and then in our new deployment stuff, it took a long time to get in there. But anyways, that's agility. And then also another one is, somebody comes over and asks me something, like somebody from security team comes over and asks me something, and I'm like, you know what, you'll get an email in an hour. That's how it used to be. What would be better is I say, oh shoot, can you show that to me? And as they stand over my shoulder, I pull up whatever I'm doing, and they go, it's right there. You see how you're setting whatever mode to the wrong thing for this file? Can we have it set to this and then this ownership? And I fix it right there, right? In whatever I'm doing. Then they go back to their desk and they check it. And now there didn't have to be 400 emails, and we didn't have to fight up and down the chain on how stuff works. I just work with the person. Now, you might say, but what that slows you down, this and that. Guys, look, none of us are doing something that's so complex that we have to be like, I don't have a hat in here, but like I have to put on my thinking hat for 4 hours of deep technical thought, and I have my drum and bass music all loud, and that's the only fucking thing I can think of for 4 hours. I don't even eat during it. No. I know like 3 guys like that in all my years of engineering. Most of us can at least go, oh yeah, hold on real quick and fix it. And even those guys, they could if they wanted to. They're just curmudgeons and they don't want to fucking work with anybody, right? Anyway, all right, I'm swearing. I'm going to stop swearing. But stand-up meetings, very important. Very important for you to understand because it's going to hit you like a truck if you're not used to it. All right, ECBs are cab meetings. This deals with what we were talking about earlier. As an engineer, you could sit there and fret all day about things, but what would be better is just push it up to your change advisory board or engineering control boards or whatever your company wants to call them, and your change management team. Yeah, Flavobox. Yeah, I lose my mind sometimes. People online will make me mad about something, and then I'll just be mad in general. But anyway, so we configure systems correctly, we hope, and then we push them out into the night. I always tell you guys, like with my servers, like when I build servers or when I build a process that builds servers, that is almost like a shipyard. It builds up my server, and my server gets pushed off into the night. And then the deckhands are all of the like little dev guys that are like running around putting code on there and doing all kinds of other stuff. How's it going, Moop Moop? Hopefully this stuff's useful. We're going over different stuff. Oh, I missed the thing. No, I didn't miss anything. That was over on the YouTube side of things. But guys, we do have YouTube. You guys can watch over there as well. I don't know how long those stay, but I think YouTube's pretty persistent, so hopefully they stay over there for people that want to see this stuff. We did labs all morning. We always do labs all morning on Sundays, but then we jumped over and we're just talking about this stuff for a little bit. But our change advisory board, everything must be submitted to ECB. And the reason we do that as an engineer is because then there's a record of the change. Other teams can reference that change. We can reference that change. We did 4 Ansible labs. We talked about Ansible in different ways. Actually, 5 Ansible labs. Jumped around a little bit. And then now we're just talking about kind of soft engineering skills. And people are like, oh, there's no such thing as soft or hard engineering skills. All right, I'm going to differentiate them for people because I'm not going to argue about if they are or not. But hard engineering skills are like, I can put this into a system and it will pump out something. It will give me an output. It will write a CSV. It'll send an email. It'll build a server, whatever. That's a hard skill. That's like a technical, implementation of a thing. And then there's the things that like allow me to interface with management and other engineers and that kind of stuff. And I call those soft skills, and I call when I touch a system like a hard skill. If you don't want to make that differentiation, you don't have to. Nobody has to. But I'm just going to tell you that's my differentiation. If one makes my life easier so that I can surf on top of the wave of change management and like I remember at one time at Lockheed, I had 4 different types of managers over me. I had an L code manager. I had a line. That was the line manager. I had a project manager. One thing that we called the I forget what they called those other managers, but they were basically like they were the managers over each of the different so we had project managers, then we had a thing, I forget them all. I don't even remember anymore. Lockheed was so long ago for me. It was like almost 10 years ago since I was working there. But I remember I counted out one time 4 different managers over me. So change management, right? We have to put in this change information. What's the complexity? Is it simple? Is it routine? A lot of us have routine management, and routine changes can just be push a button and change in the environment. So adding a disk to a server depends on, there's times when I've seen a server disk add cause the server to crash. Very, very rare though. So maybe that one gets allowed by most people, by most teams and companies and stuff. But if you want to make a change to like a production load balancer, they might be like, let's do that on Saturday night when we don't have too much customers on the system in whatever our defined downtime is, right? What's the expected downtime, length, and impact? So what servers are we going to hit? What processes are we going to hit? If we have a load balancer that's having problems in AWS and we need to redeploy that load balancer, that's going to be hard to do. But if instead, in front of that load balancer, we had a second load balancer over here, and this load balancer does load balancing against all of the environments, and this load balancer does load balancing against all those environments, and we have that split through a multi-part path in Route 53 DNS. Now I have highly available load balancers to highly available backend systems, and I can probably take one of those down after 5 p.m. on a Friday when it's not going to be that big of a deal, because we're still going to be able to handle the load of traffic on the other path. And we're not going to get into everything in AWS, but that Route 53 DNS will be doing load health checks, and it'll see that the one goes down. You can even inform it the one goes down, so DNS caches die, because DNS caches tend to die every 10 minutes. But you cannot ever guarantee, this is a rule of the internet, you cannot guarantee that the client side is listening to what you say the cache out value is. A client doing bad things on the internet, and when I say bad things, I mean doing things badly. Clients on the internet can cache DNS forever. They can remember forever what they were told. But a good client, and this we're talking mostly web clients because the application is almost always the web, or the web portal is almost always the application nowadays. We don't build a separate application. We just run shit in a web browser, right? They should be able to get in because they've forgotten the DNS cache and they're not going to your old load balancer and failing. But anyways, that's neither here nor there. What's our expected downtime? How will we be performing the changes? Who will be performing the changes? Is it me? Or did I test it a bunch and now I'm going to hand it off to one of my junior engineers while I'm out of the country and I can't even log into the system? That's something to know, right? Has a change been performed and tested in a lower environment? Do we have like a dev, a QA, a test environment before it gets to prod? And prod is always the last environment. It's always customer facing. But you can define those lower environments as much as you want. When I worked at Lockheed Martin, we were the factory to a government project, and we had 17 environments that we ran and worked on before something got deployed to the government environment, and then there was like 5 or 6 environments over on the government side before it went into prod. That was a pretty rigorous structure that we had there, right? And then another one is rollback plan. Can we roll back? Not all things can roll back, guys. An upgrade of firmware should be able to flip back in most switches and different devices to an old version. But some older switches that are out there and some older layer 3 switches and routers that are out there, they don't have enough space in them to run both versions of like an iOS in Flash, Internet Working Operating System, not the Apple one that came later, but the Internet Working Operating System. Some of the older ones, you could only have one at a time. So your rollback plan was to reinstall the old one after a TFT pull that might take 10 minutes. That's not a great rollback plan, but have you at least thought about it and have you at least tested it to know we could roll back if we had to? So we go forward because we tested it and we think we can go forward, but then something's wrong in the environment or a config is holding on to an old value that shouldn't be there. Can we roll back to an old version? This is what we do. And then changes must also get approvals before going to the board. One of the most important approvals is the asset owners. So I don't want to do anything, but I have to patch a bunch of servers. But God, running servers is like your I'm gonna skip this song. Go to another song. The running servers is like I run a fleet of cars. I got a fleet of Toyotas, and I'm responsible for changing the oil in them. But you guys all of you out there in Twitch world and YouTube world, you guys control the cars and let your teams drive them around. And I just keep saying, bring those cars in so I can patch them, but you don't ever have to do it. Well, in my mind, I'm not the owner of that process anymore. And I used to argue this all the time with managers and change management. I'm like, if I don't own the ability to say yes or no, I don't own that process, right? Like if I can't just patch that server because it's out and about running around, I can't, So the asset owner is the person that owns the server. Like, so the security team manager or the director of whatever has to give me those assets and allow me to do work on them, typically in like a well-defined window or something, right? So engineering change boards and engineering control boards, these are things that you're going to run into as an engineer. You're just simply going to run into them. It is what it is. All right, fit for use and fit for warranty. This is the way that we make sure that what we're providing, we always have customers. Whoever you are, you have a customer. If you're internal as an engineering team like me, my customers tend to be the different people on my team. The different people in like dev teams that are asking me for things, and then I'm providing the ability to build servers, or I'm providing maintenance on servers for them. And fit for use and fit for warranty speaks to how well whatever I do meets some capabilities. So fit for use is, does the system do what it's supposed to do? This is the same as functional testing. It's, can I check a bunch of boxes? Is it a Linux server running a 7.9 kernel or a 7.9 OS of Red Hat, and is the kernel version 3.10. whatever? Check. Boom. Oh, Moop, we're on ads? Okay. I won't talk too much. I'll just sit here and sip on my water for a minute. For people on YouTube, I guess you're not getting ads, but everybody else is, so I'm going to wait a second here. Let me put myself on mute so I can crunch. I found that you guys don't like when I crunch those live, so give me another water bottle over here. All right, 46 more seconds on ads, but that thing's never timed right, so I'm going to give it a second here before we start again. And then we'll go talking about this stuff. All right, moves back from the ads. All right, so we were sitting here, and I was just saying that fit for use is checking boxes. Is this thing a Rel 7 server? Is it running on this kernel version? Is it full? Does it have a 600 gig slash, var ww directory? Does it have a separate 600 gig opt directory? And these are things that I can just say yes, 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 and yes. That's fit for use, and that is functional testing. Does the server do the things I need it to do? This, by the way, comes directly from ITIL. ITIL defines this, and I really like their way of kind of talking through this stuff. But non-functional testing is fit for warranty, and that is, fit for warranty is, does the server do what it's supposed to do as often as it's supposed to? And it speaks to stability. It's also something that we might call how the server behaves in the wild, or what we might call non-functional. So This might say it's got an Apache web server on it and it's serving port 80. That's fit for use. Check, check. It's an Apache web server, it's on port 80. Fit for warranty is if 4,999 users use it and a 5,000th user comes and uses it, does it stay up? Yes. This is how the vehicle drives. This is what the vehicle is. It's got 4 wheels on it. It's got 4 doors. It's got a steering wheel, a gas pedal, brakes. After I hit that brake pedal for the 2,000th time, does it still stop the car before I get to the intersection, right? In the server world, fit for use is, is it the right, everything, has it checked all the boxes and hit all our GRC requirements for security and all that stuff? Cool. Fit for warranty is, does it, after the 15th person connects to it, does the server just fall over? That's a problem. And fit for warranty, if you have a hard time remembering these, a warranty is the idea that I guarantee that the server, I guarantee at the risk of you calling me out on a Friday night at 8 p.m. when I want to be doing other things, I guarantee that the server will work under most conditions. That's for what fit for warranty is. So if you've ever heard somebody like, we warranty it for 80,000 miles of the drivetrain of the vehicle or whatever, that's what fit for warranty is they're saying that if it breaks before then, you can call them. Well, if you're the one running the servers, you're always going to be called. So you want that fit for warranty to be as good as it can. This server can maintain whatever types of things you want. And you might say, well, Scott, how do I load a server up with 5,000 users for tests? And how do I do that? Well, we can do benchmarking and baselining. We can baseline and see how the system works under normal operations. We can benchmark it once we start to see the server in actual production use. But then we can use those numbers that we're getting from our prod environment to try to mirror that stuff in our dev environment. So what we can do in the dev environment is spin up Stress or one of these high processing type tools that we have like DD and just zip a bunch of files up. I've shown you guys how to do this in other labs and stuff. And we'll spin that server up and then we'll start the web server on top of it. So now the server's under tremendous load and disk usage and stuff. And then we use Burp Suite to hit it with 5,000 users in a second or something. So we can build technologies that functional tests are easy. It checked all the boxes. But non-functional tests tend to make us think outside of the box, make us hack the system around to see how the system behaves in the wild. Okay, that's what that terminology is. That's how that works. All right. HDITM and WIIFM. Some of you guys have heard me talk about this. This is one of the most important things when you have to talk to management or other users of your system. HDITM and WIIFM, one of the most important things you can do whenever you talk about change in an organization. They are, how does it threaten me and what's in it for me? If you are presenting information about an upcoming change to email to users, and you're like, hey, okay, for all you devs, you guys are used to just going, sending this one I did a few years ago. You guys are used to just going to any Linux server and just running send mail and kicking it off, and it hits our open POP3 relay on whatever port, and it sends the mail. That's how send mail, that's how postfix used to work on our systems. You just run a mail or a mailx command and you send it. But the security posture of our organization moved forward, and the security posture of our organization is you can't have an open mail relay even internally. Every piece of traffic must be authenticated. This is a security posture that we run into. So what the teams did was they came to us and said, well, hey, can't you guys as a Linux team just go in and put in a base user account, and that user account will sit there and authenticate to it for us, and whatever our application is will just send mail like normal. And by the way, hold on. Technically, could I do that? Yes. But that would have been like, we've locked down the city buses, but what I did was I just took a chain and I chained my badge to each of the little things. So when the city bus came, you could just run my badge everywhere and get onto the buses anyways. Do you guys see how that's... As a systems engineer, your job is not to bypass the security requirements of the company. If your company has moved to a certain security standard, and by the way, you may say, I don't like that security standard. Well, you could either get that standard for your organization changed, or you can get yourself fired, I guess, or you can move on to somewhere else that has more lax security standards that you like. But I'm going to tell you what I did in the team is I said, guys, I can't do that. What I can do is this. I can program half of it. And half of it was across the whole systems. All the servers had the certificate to trust only that one server. And then what those teams had to do was build for any of their users or service applications or whatever, they had to build their credential file locally for them, and then they could call that file and get their application. So they could use their bus pass for authentication and authorization. Oh geez, what's the first one? It's not accountability, not authorization. It's how we know they are who they say they are. What the hell? I'm drawing a complete blank in my mind on this, but they can do that part and the second part and make sure it's them, and I'll just make sure that my system's always pointed at the right server. What the hell is that? It's yeah, authentication. Yeah, you are who you say you are. Yeah, C-top, that's it. It's authentication. Like, they can authenticate as themselves. They can get the authorization of who they, what permissions they have. They can do that top part, and I'll just do the bottom part where I always point at the right server for them. So I conceded and did that part for them. But when I was explaining that to them, in fact, it's really funny how this happened. The team that deployed this was our like productivity and office team, and they were changing that in the way that Outlook worked, right? And the way that Outlook was doing mail relay in our organization. Hold on. So it came down and they told it to everybody, and us on the Linux side, because I was a platform engineering lead at the time. I looked at that and I said, well, hold on, this is going to break all of our stuff, so we've got to tell our users. So then our users, which is like 200 dev teams, they started yelling at me for a fix. And I'm like, guys, I'm not the one changing it. And they're like, well, do this thing. And that's when they came up with the bus pass thing. Well, they came up with just doing that. And I said, that's like me doing a bus pass. And now I'm just bypassing the thing because anybody can be on the server using the bus pass. And that's stupid. We might as well not have made the change then, right? And because it's still just open authentication. Everybody has the same card. Everybody's the same. You're basically just using the server to authenticate. That doesn't make any sense in what the posture of the organization was. So I was stuck between a rock and a hard place. These guys were like, have you made the change yet? Have you made the change yet? It's going live. And I'm like, I'm trying to get the dev teams to make the change, but honestly, break it. That's what I said. I said, do it. Just kick it over. And they started tracking which ones had not done it, and we got the people moved through and stuff, but there were still some that didn't get it. But the point was, like, I wasn't going to sit around and hear it, but we did hear it a lot. And again, I'm just an engineer, so I heard it from my manager who's getting hammered by people like, why is our stuff breaking? It's like, we've been telling you for a year now. So yeah, authentication and authorization was on them. We just made sure that you were pointing at the right thing. But anyways, so whenever you change something, people are going to ask you, how does it threaten me and what's in it for me? And if you're like giving a presentation to a bunch of engineers and you're explaining how this new change is coming and this Outlook change like we were just talking about, I'm telling you right now, until you answer these two things, those people are not listening to another word you say. I say right here, effective communication stops once people get scared if you do not answer them. If you don't say at the front of it, to the average user, this won't mean anything because your desktop's automatically going to be configured, they will not ever breathe that sigh of relief and start listening again. They will simply be sitting there going, oh my God, I got more work to do. Oh, that's what the average user is going to do. Users are going to user. That's how they live. Users basically, I think, live in a state of panic and fear at all times, right? But this is any change. I don't care if you're in technology. You could be going to tell people that they have to drink from a water fountain a different way every day. You got to walk around to get there. People are going to be like, how does it threaten me? Oh God, I got to walk further every day. I'm not going to be able to get water in time. I'm going to probably die in the hallways, right? People think like this. And if you tell me people don't think like this, I don't think you've ever, I would tell you I don't think you've ever talked to people. People immediately get scared when you tell them there's a change coming. And until you allay those fears in an organization like this, have you guys ever, classic example from the last 2 years, I have been called into at least 5 times in the last 2 years in different organizations, mostly in AAA because they let a lot of people go. I have been in places where they're giving, it's a big all hands, and they wait until the very end in those all hands to tell people whether or not they're actually letting people go. And I'm going to tell you right now, nobody there, including me, can even tell you what was talked about in any other part of that meeting. They're talking about the business is doing good, our numbers look good. None of us heard a single bit of those first 50 minutes until they said, yeah, we're downsizing 50 people from this department. You'll know by the end of the day. Nobody heard it. And then they're like, none of our engineering teams are getting affected. once that happened, and guys, I'm guilty of this too, that's when I started listening to the rest of the meeting. Once I knew that it wasn't about me. But I'm telling you guys right now, if I guarantee you guys, some of you have been in these meetings, and you're like, yeah, nobody was listening. Nobody had any idea. We're all talking on Teams, like, what the hell are they talking about? Are we getting let go? Is the whole department getting shut down? Like, nobody, until those are answered, all communication stops. So this is not really an engineering thing. Again, this is a soft engineering thing. This is how people interact and how things happen. So if you ever have to give a presentation on some change that's coming in an organization, if you lay these things out up front, you will have a successful communication with that group. If you just start talking about problems or things changing, just know that you've caused problems and consternation in people that will not be resolved until you tell them it's not going to threaten you. It's not, no changes for you. It'll all be automatic on the backside. Whatever. All right, presenting data. This one bugs me to like no end. And I'm going to show you guys some stuff from some of my college students. I think I've even added in the new stuff. But I learned this. This is one of the most important things I learned in my master's program. There was a guy he was a very successful, he ran a bunch of like car shops and stuff in California. I forget his name. I could probably find it if you guys are interested in dropping it in Discord. But he ran a very successful set of like garages in California. And somebody asked him later on in his career, they're like, you barely had any high school, you didn't do any college. How did you get to build a successful business? And one of the pieces of insight that he gave them was, he said, I learned very early on, it didn't matter how well I could build a business. People judged how well I could do that by how clean my bathroom was. So what he did was he just kept his little area that you sit in when you wait for your car very nice and clean and very tidy and stuff. And he always had a lot of business, and that made him grow. By the way, side note, anybody here ever been in like a Wawa? If you're on the East Coast, if you're on the West Coast, it's QT. QT is a huge one right now. Have you ever been in one of those two places? And have you ever been in a Circle K? Circle K versus those two. If you've been in a QT or a Wawa, those are different sides of the country. There's probably one in the middle that's similar. QTs and Wawas are always clean. They're always fast. If they get 3 people in line, they call another person up, and they're like that, getting you out of that place. All they care about is getting your money and getting you out of that place, and it's always clean. They always greet you at QT, and it's always like, oh yeah, hey, like I'm back, yeah. Have you ever been in a Circle K? They're like, fuck you, man. You're the 6th person in line. I don't give a shit if this guy takes 20 minutes doing his scratchers here. I'm not going to ask him to move. Circle K doesn't give a shit because they're Circle K and they're all over the place, right? But these new up-and-coming places, they really adhere to this. So if you've ever been in those places, I've been in a Circle K where like I'm the second one in line and the guy in front of me is just like multiple times over and over again asking for more stuff, like more like scratchers and stuff. And then they won't even scratch them; they'll just scan them and then do it. And it's like, shouldn't this guy at least like tell them, hey, move over and you can do that stuff, and then we'll let these people go through and you can continue? No, they don't care. But that's not how all organizations view it. So, anyways, this is a thing about how you present data. Not necessarily about customer service. Maybe I should add that. But this is my talk, and I give this to all my junior engineers. I give this to all my college students. So I've probably showed this to a couple thousand people over the last few years. But this right here, if I'm ever included on an email, because I get included on emails all the time, and it looks like that in the top left, I'll send to my engineer, why didn't you just tell him to go fuck himself? Because honestly, and I use that language, I don't care. Why would you send that to anybody? I've been doing this stuff for 20 years. I can't read that, right? But if it came out of a terminal, leave it like in a terminal format. This is Courier New. That's the way you do it. And yes, I have told engineers exactly that. Yes, multiple times. Like, why don't you just tell them I'm not going to tell you the answer? Like, it's literally, this is like, why don't you just spit on the page and send it to me? This is terrible. And I'm not being like super like, I don't know. Anyways, all right. This is another one. Take pride in your work, man. Every single thing this student put right here is correct. I could go to our networking primer. We did the networking primer again yesterday, and I showed this. But then we also have a recording of it up on YouTube for some of you guys that want it. But I show how to break down a /25 network. This right here that this student did is 100% accurate. There's nothing wrong with this. But can any of you read that? I mean, you're not feeding it into a system like that. This is coming to a PowerPoint to show to people, and presumably you want to do it for whatever. Yeah, you need to be able to read it. Hey Keybind, thanks for the raid. Hopefully you guys had a good stream over there. Maelstrom, you just said like when you get a bug report and you don't get any IDs, usernames, timestamps, screenshots, so you have to type it out yourself. Yeah, yeah. Like, I mean, it's pride in your work, and it's not. Again, it's not pride in your work for pride in your work. It's pride in your work because somebody else has to take this. One of our guys, Sending Grounds, who's excellent, and not Sending Grounds, Salty Catfish. Salty Catfish is a guy I know IRL, and I've worked with him a couple times in different projects and stuff, and he's a programmer. And he always says on his stream, he's like, we don't do this stuff. We don't write our code for the computer. He goes, yeah, sure, you write the code so the computer can syntactically interpret it one time. But the real reason you're writing the code is to be readable by you later or the next person that comes to maintain your code. And he's very adamant about that. And this guy's been doing this a long time. Yeah, Keybind, I appreciate you coming by. I appreciate you trusting me with your community. If I don't think I have any mods here right now. All my mods are off doing other stuff. But shout out to Keybind. Hopefully that works right. You guys should follow them. This is a, follows are free, so you should definitely be following them. And I appreciate the follows that I'm getting. You guys are always welcome to hang out here if they're not around. I tell people all the time, follows are free, right? You can do whatever you want with them. But I did 5 labs this morning on Ansible. We have a bunch of labs out there in the world that are free. They're on Killer Coda. If you find nothing else from this stream, Killer Coda is the best thing out there. It's got nothing to do with me. I just maintain 54 labs, I think, now up there. Yep. And yeah, follows from Kazabu and Keybind and Cyber Official and Arsaka. Hopefully this stuff's useful to you guys, right? Like this is like what we do here. But I'm talking. I stepped back from the hands-on, which I normally do hands-on all Sunday morning, and we're talking about like soft engineering skills. And the way I differentiated that is hard engineering skills are things I program into a computer and type and that kind of stuff. And soft engineering skills are like living your life interacting with other humans. Because we're engineers and we interact down to systems, we interact down, and then we also have to interact up to our bosses and our management, and sometimes for me to like college students or my junior engineers and that kind of stuff. And I'm just telling you guys, like you gotta, there's certain things you gotta do. I like the smiles and the drug. You'll find that I'm pretty straight edge in that respect. If anybody cares about me, I have a whole bunch of certs. I don't really care about certs, but I get them for fun. And I've been doing this for 20 years. I've been a college professor of this for, I don't know what now, 15 years. And I just started earlier this week my doctorate program for this as well. But my doctorate program is going to focus on quantitative analytics. And but like I'm like a system and a platform engineering guy through and through. We do Linux here. That's pretty much all we do. That's pretty much what all of our little stuff are that pop up if you follow and stuff. All right. So again, now we're going to talk. We're not necessarily like being off crazy about stuff, but I'm saying as engineers, what you do is search for truth. So be above reproach. And what I mean by that is, I never want to, even late at night, if I get called out or if I build a system and I send over that it's done, I never want somebody to come back and tell me that what I did was wrong. That's like the worst thing for me because it stops everything else I'm doing. I thought I was done on that project. I had tested it and I checked all the boxes and I had done all the things. And then it's almost like in one of those shows where like the anybody here ever watch oh god, what was it? It's the Bluth family, and he's a loose seal, and he gets his hand bit off. Oh, Arrested Development, right? If you've ever seen Arrested Development, it's like the it's like the record scratch stops. Like the record stops, and then it's like, but it was not all good for whoever, right? And like this narrator's going the whole time. We say that, I always say that engineering is the search for truth, but I've been on calls. I've been called out. I've been like, I'm an escalation point always on my team, so people always come to me, and I'll be on a system and they'll be like, hey, the system is down and this and this and this, and we're trying to get in there, and the very first thing I do is SSH over to that server and it's up, right? Hey, Wusa, yeah, thanks for coming by. But yeah, the very first thing I do is, oh, wait, is my system? Oh, this system's down. So I go in, and the first thing I see, they tell me the system's down, right? That's what I get when I get on the call. Very first thing I find out is the system is in fact up. But nobody on my team checked. They just trusted, and we've been running off. I'll go screen. This is my environment. Those are all my home lab environments, right? Bunch of different stuff going on out there. But nobody checked to see if the system was actually up. They just trust that it's down. So I say, wait a minute, the server's up. Everything's up and running. What do you mean it's down? And they're like, oh, no, sorry, the service on the server is down. The web service. And I'm like, that's totally different. And guys, I couldn't tell you how many hundreds of, maybe even thousands now in my career of hours of engineering and management time that have been wasted on calls because somebody trusted what somebody else said to them but did not verify the truth of what they were saying. So what I mean by that is we're all scrambling around and trying to figure out why the server's down, but nobody has checked that the server's actually up, let's say. Then I go and I check it, and it's like for all of those 15 minutes before I got on that call and actually went and checked, everybody was off assuming other things. When what we really find was somebody restarted the server and we just hadn't enabled HTTPD on that new set of servers that had just gone live last weekend or something. These kind of things happen all the time on builds and stuff. So, Andre, I'm 42. Not that that's what you're asking me, but I got the Bacula certification in 2020 on the NOAA project, the National Oceanographic and Atmospheric Agency project. So it's kind of funny that you said it. Yeah, and a lot of engineering teams, we don't level set what we're talking about. So you get on a call and everybody's running different directions. So this is why I'm telling you guys, trust what you're told, but verify it. And then also, if I say something on a call or I write something in an email to state some truth, I always back it up with proof. So earlier, this one here, where it was like, if I were to look at this system and somebody were to have told me that on that server, they're like, hey, you know what, the temp directory on that server is sitting at 98%, we can't put anything else in it. And I go to this server and I say, hey guys, I don't know what you're seeing, but on that server, which I'm on this server, I can see that the temp directory, there's no other mount for temp here, guys. I can see that. The temp directory of it's actually only at 50%. But I would also check it. I would actually go to that server and I would do a df-h on temp. And I would say, yeah, it's actually there. It's at 66%. What are you guys seeing? And then you come to find out they're on the wrong server. Or one of their junior engineers sent the screenshot, but they were on a different server than the jump server or whatever they were supposed to be on, right? Yeah, Wusa, I'm 42. Yeah, it's the same answer for the meaning of life in the universe, right? But we don't know what the question was because Earth got destroyed right before. Anybody know what's that reference? Who knows what the reference is? All right. If I write something down, I always back it up because I don't want people to come back to me later and say that I haven't given them the right answer. I try to give people accurate things because I don't want to have to backtrack on what I've said. I don't want that. I don't think that's good engineering when all engineering is giving good answers and correct answers to people according to whatever truth you can find in the system. Even if that truth is ones and zeros, right? It's all whatever. All right, here's another one. Engineers deal in precision and truth. Avoid talking about your feelings. I feel like the system's going slow. Irrelevant. If I was on my other system, I could show you guys all my monitoring for my home lab. I'm on my backup internet because Cox is absolutely terrible internet. And, but I can check, I can actually see how used the system is right now. What's the uptime on this system? Compare that to an NPROC of how many processors I have. Yeah, the system's under high load. And it's been under high load for quite some time here. But if I wanted to watch it while we're on the call, we'll do sleep 2, done. I can watch it while we're talking. And then as I'm talking to people, I go, yeah, the load's pretty high and the load is staying high. At least for the last 15 minutes I've been watching it. I can watch this right here. I can also see, one thing I love to do, I always do uptime immediately when I get on the server. What's the uptime of the box? Has something changed? If a server's been up 174 days and a process is down that has been running, somebody changed something. Almost, I would say almost universally. Or some threshold was hit of memory or CPU, some wait got too long and some queue failed or something it's communicating with was down. Something changed. But if a server's been up for only like 10 minutes when I get there, I know that something's broken. My environment, my poor lab environment's been neglected for a while. But that's like in my home environment. In my work environments, I normally don't see anything over 60 days. But I can still tell if something's been rebooted recently. All right? Learn how to interpret the data you're looking at. So if you tend to look at data or you don't tend to look at data, but now you are looking at some scope of something that somebody's showing you. You have to understand scope and scale and understand your mean, median, mode and what is a distinct outlier. So if you're looking at, some threshold going up like this, and it looks like a real sharp uptick, again, I can't show that. I used to show this when I had my Grafana up. I would show it where if I move it out like this, it looks like a flat line. But if I move it real close, it looks like it shoots up at a angle, because the scope and the scale of things are not accurate. I can make between 70 and 70%. So sorry, 70 and 71% of disk usage. If I make the low and the upper limit of my graph 70 and 72, I can make it look like that. Over the course of the last hour, look at that growth. We're about to hit 71. But if I change it to 0 to 100%, and for the course of like the last month, it looks like this now. Now it's a flat line. So there's an old saying about show me a statistician and I'll show you a liar. It's true. Or the very famous one. You learn this the first day of any statistics class in college. This is every statistics professor I've ever known uses this one. It's there's 3 types of lies: lies, damn lies, and statistics. Have you guys heard that? Anybody here that's been in a statistics class has? Go watch Go watch a video on YouTube about statistics. I guarantee they make that joke or the other one of those two, right? Anyways, avoid all anti-methodologies for troubleshooting. People love to just change random things until something works. That's a really bad way to troubleshoot. Communicate what's happening on a call. Let people know, hey, I want to change this. Is everybody okay with that? Make sure that that's being recorded by a bridge call or whatever. If you don't have a bridge call and you're the one trying to fix something, you should be taking notes and setting things back so that when you do finally fix the thing, you don't have to go and unscramble your, string cheese of things that you changed before you got there. Because maybe all your other values were right and you kept flipping bits until you got there. Now you can't undo and unzipper all the problems that you've caused or whatever, right? So these are the things that we try to avoid. Spotlighting this is a bad one. I know how to use a reboot, and that's the only thing I use. I reboot things and I only do that one thing, or only use tools that you're familiar with. You should be able to look up and use other tools as long as they're observational tools and you're not going to change something in the system. That's a good one to know. And then this one, I tell all my junior engineers this, I tell you guys this: do not get on a call and say looks like the network. That is the best way, one, to make enemies in the company. Even if it looks like the network, don't say it. Everybody probably already said it before you got on the call, first of all. Second of all, why would you want to piss off all the network engineers, right? Why not just gather your data, prove the things that you can say, prove the things that you know are true, and then say, it does not look like it's in my system. I've checked all these things. I can't verify. Hey, can we check to see if there's some firewall change or something between my system and that other one, because I cannot get a connection on, you said port 2049 is supposed to be open from this server to that server and it's been open before. I can't get over there. I'm not seeing what you described as that behavior. There's something outside of the system possibly stopping it. That to me is not starting a fight with networking, but that's going to almost, God, I've seen this like 10 times, where like we're locking stuff down in an organization because we've went away from the big open, everybody's protected inside of the organization, to like we firewall off different environments, and almost universally somebody pops up, they peep up from the back row and they're like, oh yeah, we dropped some firewall changes in on those PCI environments. Yeah, so no, it makes sense that doesn't work. Hold on, let me punch a hole open for that, and then that production system starts working. And then look, we can point fingers and we can argue and we can have the root cause analysis fights the next day when everybody's cooled off and stuff. In fact, I like to let the managers go have that fight because that's not my fight to have. The system broke because of some other change that happened. My whole job was just to prove that all of my stuff was good. So I tell people all the time, like, you don't have to be this engineer there sitting there like this, like ready to fight people and gritting your teeth and ready to like lose your shit and cause all your hair to turn white because you're having like a spastic moment. Just find out what it is and tell it to the world, and then let them go fight over it. And if they're not picking up what you're saying, you might have to be a little more direct. But my point is, you can ask somebody without just blaming them directly, and that's I'm telling you right now, man. Like I've watched my engineers on call. I'll be getting called out, and like they'll still be arguing with someone. I'll be like, "What happened?" They'll be like, "They said it was the network without even checking the system." And I'm like, "Oh god damn it!" Right? It's guys, look, systems engineer and platform engineer to platform engineer. It probably is the network, okay? And they know it's probably the network, but you don't have to pile on. Let's just show them what we know, and then say it's outside of my system. I don't know. Is it the other system? Who has access to the other system? What's changed? What And these are the kind of things that I'll do. But I won't get on a call and blame people. I think that's bad form, because if somebody gets on a call and blames me, I'm never happy about it. Then I prove. By the way, how I fix that is I prove the things I know, and then I try to figure out the things I don't know to be able to prove that the system is up. It is working. The system is whatever. It's always DNS. Yeah, there's that old. I need to pull that up. I don't have that as one of my things, but I need to have the little haiku that it can't be DNS. It's not DNS. It was DNS. I don't think that's the whole haiku, but there's a haiku 575, right, of DNS. We could find that if we wanted. It's right here. It's like one of the most common things ever. DNS. If you've never seen it, here's the haiku for DNS. It's not DNS. There's no way it's DNS. It was DNS. That's the haiku of DNS. In case you didn't know, it's 575. Right? That's how haikus work. All right. All right. We did all those labs, and then down here, this is how we figure things out. And I've added this since the last time I did this talk. But for every resource has a network idiot with bright idea. The use methodology looks like this. You've got utilization of a system between 0 and 100% utilization. Once you hit 100% utilization on any resource, you start to saturate across. Saturation is the queuing and the length of things waiting to use that resource that's utilized between 0 and 100%. So now you've got your queue. And then if the queue starts to get to timeouts and other things like that, you start to have log errors and events that are happening because queues are getting too long and things are timing out. That methodology and understanding that that's how systems tend to work, and how programs on your systems tend to work, and how calls to APIs tend to work, and how like everything works. You've got a utilization of 0 to 100%. You've got a saturation when you start to queue waiting for that resource, and then you've got errors that start to come out of that. If you have a working system and then you start to see errors, look for where your utilization has gone high and where your saturation has started, and a lot of times you can find what the problem is. The use method of troubleshooting is tremendously valuable. But how do we check these things, right? We've checked these in other labs, but how do I go check? Look, we're just watching the load average on the system. We may have, that was just a load average, and I had to know the number of processors for this to matter, and anything greater than 1 here, it means wait time on the processor, right? But I could do this instead. I could say iostat-c1, let's go C5, and I can just look at the average CPU. And I could just watch my CPU now every 5 seconds and say, well, this system is going between pretty idle to pretty good usage, and I should be able to watch this. And then, by the way, I can hit a Control-C, and I think it should give me my aggregation. Yeah, who sanctioned this change? Yeah, that's another way. Yeah, that's the thing that causes people sometimes to be more truthful. Is you're like, when was this change? When did it go through? And then that's when you'll find people scrambling, and people sometimes hate you for that as well. But sometimes you just got to ask it, guys. Like, I know that's a fallout for people, and I know it's gonna maybe cause some heads to roll, but sometimes it needs to be asked. My brother works at AAA, and he had one a while back where I left AAA. I was their red team lead. I ran all of their offensive security team, and I was their lead over that. And then I left in June to come back over to Redline and kind of hang out with them. But when I was there, actually it was after I left, so it was sometime in the last year. My brother, they had this incident where all traffic stopped flowing up to the cloud. They're on this call, they're trying to figure it out, and long story short, after an hour of being on this call and this one person not piping up, even though people kept asking questions, they got like a more senior engineer on from that networking team, and he said, "Oh wait, what is this? Somebody set all UDP traffic to no longer work up into the cloud." All UDP traffic was blocked from their on-prem to the cloud. That royally effed them up because DNS stops working when that happens. You say, oh, I thought DNS was both TCP and UDP. Yeah, they're both required, guys. UDP is where you pass all the data, right? So this person blocked, everything broke. Nothing flowed up into the cloud except TCP connections for that whole hour. And then that one engineer was like, oh yeah, I did make that change. This guy had been on the call the whole time, not answering and this and this. And my brother was like, I think this guy's going to lose his job. And then he and I talked about it a few days later. He's like, yeah, that dude's gone. And I'm like, makes effing sense. You made a change in the middle of the day to the production firewall, and there was no change either. There was no change approved. And then while you were on a call trying to fix it, you never even spoke up that was the thing. It was really bad. But anyways, like we have these things that we track. In if you're doing operations for a long time, and I tend to be on the project side of things, but you still touch operations all the time. I tend to skip this one. A little too happy. I tend to have to look at these kind of things sometimes for like my team as a whole. But we have things called mean time to detect, mean time to resolve, mean time between failure. There's all these MTs, right? But it's the mean time. How long does it take us to resolve a problem? And detecting a problem and getting that fixed first is really important. But the mean time to resolve is only extended out by people not maybe pointing out the true things that they should be checking and that kind of stuff. So, all right, anyways, that's a use method. And then questions, join my Discord. Keep watching on Twitch. Discord is free. You guys can always hop down there and talk shop with. Man, we just broke over 900. I think we're at like almost 910 people now. So that's kind of good. That's fun. But that was our soft engineering skills stuff. And oh look here, we're watching the system forever, and we can see that our system's using a little bit of CPU. You can also use top, but most engineers don't use top. I don't really have any problem with it, but I can't go back and look through things because top overwrites. So if you use top like this, you can't really gather the data out of this. I prefer to use something else. Oh, it looks like ClamScan's still running on my system. That's why the CPU is so high. Yep, that makes sense. ClamScan is, I run it every night in my environment. So, all right. What else do we have? We've got our KubeVirt in our home lab environment. We've got our labs here. We just did this 8th lab. So let's do this lab. We've never done this lab on stream before, so this will be a new lab for us. And we do tend to do labs all Sundays. That's all we do. So I'm going to pin the lab here. What do I use instead of top? Something like IOStat or one of those other tools. I'm going to pin this message real quick. Hold on. Let me go find our new lab. Wait, did I do it last night? Maybe I did it last night. Let's go look at our Linux labs. I think maybe I did it last night when we were first building it. That's fine. We'll do it anyways for fun. It's variables and conditional logic. So I'm going to hit this. But yeah, a lot of times what I'll do instead of that is I'll use, instead of top, I'll use the tool that does exactly what I want. So IOStat, if it's there, this won't be there. Oh, it is there. I'll use IOStat or VMstat, and those will tell me exactly the things I want to know about the system. Sometimes we have SAR. No, SAR's not there. Yeah, we don't have SAR. Or we have to turn SAR on. Yeah, SAR might not be collecting data, so we might have to turn that on. HTOP is one that people use. I always have ATOP running on my server so I can see what's going on in the history. But most of the time, guys, I just gather data. SAR will affect system performance, absolutely. From your POV, SAR, do you use too much SAR? Yeah, I do run a mucker. Yeah, I run SAR on my systems to gather old data. But most of the time, I like to get data off my server. So I like to have something running like Telegraph or Node Exporter to get data off my servers to Prometheus or InfluxDB or something. I want to offload data in real time. I don't want my servers to be in the business of maintaining their own information because I have to go to this server and run these commands to see the data. It'd be better to get that data off the server for real, Exporters and pull, yeah, get things off. Because your servers nowadays should be ephemeral. You should be able to, we call it cattle, not pets. Pets live forever, right? We take our pets to the vet and we keep them alive. Cattle, cattle get slaughtered and turned into food for people, right? So where I'm going with that is on our servers, we need to treat our servers like, hey, I should be able to drop a new server in here, make all those connections, re-add those libraries and those tools or whatever we're doing, and it should be the same exact server with a different or whatever name. Yeah, cattle not pets is absolutely like a container mantra. Yeah, I originally had heard it from an architect that was going to all of those things in the early. This would have been like in 20. I really saw containers take off in like 2015ish, 2016. Hence Rancher. Yeah, that's actually funny. Yeah, that makes sense. I never put that together for Rancher, but that makes sense. Yeah, cattle not pets is absolutely the wave. So this one is how I'm trying to do more of the labs in the future is give you kind of like a little bit of a story. But this lab is pinned if anybody wants to do it with me. You guys can do the lab. Our labs are focused on basic Linux stuff. We go through, if you look at our labs, Linux labs are like system checking, looking at our kernels and packages, disk, networking, SSH and SCP to copy things around. And then this one is variable, condition, and logic. So this one is about looking at the system and getting information out of it, right? So you've decided that you need to start gathering system information so that you can use it in scripts. You want to be better at scripting. You need to go look at people's scripts. You need to, whatever. You know that this will give you more capabilities for automation and collection of system state. And it will. Like, understanding how this stuff works will greatly help you, I think, as an engineer kind of moving forward, right? So I say check your bash environmental variables, create some variables with system data, and then output those variables to the screen. So let's see if we can do all those things. We can do a print env that's going to dump a bunch of information to our screen. That's good. We can also do env, and env will give us a bunch of the same type of stuff. In fact, it's almost exactly the same stuff. The only thing that's different is how it was called. All the other stuff was very similar. I can do a declare-p, which somebody pointed out on stream the other day. I had never even seen declare-p. This will give us a bunch of information about variables that are available in our system to look at. Here's a bunch of variables, all kinds of them. Then I can say set. Set is another good one. This comes from people that like to write a lot of bash scripts. Set will tell you what's going on inside of your environment, right? All of these things can be called as a variable. Like this Debian front end, if I want to know my Debian front end is non-interactive, I would say echo $Control-Shift-V in this environment, and it would give me the output of that one line. So I'm going to do set grep-i for front, and now I echo that out, and it gives me that value. So it's almost like I can play a ping pong game where I can say, hey, what do you have? And it says, hey, I have a thing. But if I look for something that's not there, like it's going to go in the lab here in a second, name is not there. So name is empty. Name is a label on the side of a box, and the box has nothing in it. That's all it is. So if some of you if you're watching the stream, you could be anywhere from an early beginner to somebody who's been doing this for a long time. For the early beginners, all a variable name is a place that you're going to go reference to look in the box to see if there's something in the box. And right here, like we were saying yesterday, what's in the box? There's nothing in the box. Nothing in there. Name doesn't have anything in it. Debian front end does, and that's what it has in it. That is the everything you need to know about a variable for now. Later, when you get more into how they work and stuff, there's a lot of different stuff that you can deal with. But for right now, we don't care. Let's do our print env. So we'll do a nice little way that I like to check that things are even or similar. So I can tell that there's probably some similarities here and some similarities here between these different things without having to go look at them. Yeah, we could still go look to see if they're different. We could throw them to a file and do a diff on them, but that's probably pretty simple right there, right? So then I come down here and I say test the output of a variable name. There's no variable name. There's nothing in there. But if we do a uname, which will show us Linux, and then we put that uname into that name variable, and then we call that name variable again, now the output from that command that had given us Linux is going to be captured in that box name. So when we go look in that box, there's something in it now. That's it. The box that HeroSen is carrying down the aisle right now. Inspector, were you here yesterday when I was talking about Snow Crash? I don't know if you've ever... Is it Neil? What is Neil's, Neil Stevenson? Stevenson. There we go. Yeah, I don't know if you were around for that, Inspector. Oh no, I wasn't making any of them, any UHF reference, but that's probably that. But Snow Crash is a book by Neil Stevenson, and the way the way that works here is, or the way that book worked was when you mentioned that name. Hold on, when you said Hiro-san, he has a character in his book that I think is like the most. I think it's the most arrogantly named character I've ever seen in all of fiction, or in all of any of this. Yeah. He has a character whose name is Hiro, Hiro, protagonist. That's his character's name, and he is the hero protagonist of the story. So it's kind of funny. All right, let's keep going. We're gonna keep going. We're almost done here. So I can run this, and I can set some variables, and then I can check those variables by echoing them out. So echo $HTTPD check, and it'll echo out 1, and I can do SSHD check, and it'll echo out 0. And now, real quick, if I'm looking at this, hey there, Wusa, thanks for running the little student command. Lets me know that you're here hanging out. The HTTPD is not running on our server. We see that right there. And the check is a 1. So a 1 is a failed check. 1 is going to tell us that the process is not running. A 0 for SSHD check, when we just saw that SSHD is running on our server, is going to exit as a 0. So now we have a way to... I always tell you guys, like, it's easy to look at a server and go say, HTTPD is not running, SSHD is. It's easy. For me. And for you. Once you know those commands, it's easy. But we got to make it logical so the server can do checks based on it. So we just made it into a 1 or a 0, which we can test for truth. We can test for 1 or 0, right? That's very valuable to us. So we're going to make sure that 1 is running and 1 is not. So we did. And then I said test the decision structure of bash. So we're going to use bash a little bit to test single alternative, dual alternative, and multiple alternative structures. Test each of these structures with the variables you have from the previous step. I said use the single alternative structure to output whether or not HTTPD and SSHD are running. So we run this, and it says HTTPD is not running. Then we run this, and it says SSHD is running. Then I say, are these what you expect? Can you make them logically incorrect? I'm going to go up to the first one, and I'm going to make it logically incorrect. I'm going to do this one. I'm going to make this one logically incorrect. And did anything happen? No. Because in a single alternative structure, if the test that you test for doesn't evaluate to true, well, or false if you negate the test, nothing comes out. The system doesn't have to do anything. It just passes along procedurally down the checks that it's doing, and it never has to do anything. So we broke the logic of that. Now I say, do this next part, and I'm going to go ahead and set those back to... actually, I don't need to set those back because I didn't change the variables. I just changed the test. Now I'm going to run this, and I'm going to use a dual alternative structure. Dual alternative structure is going to say, if this, then this, else this. I'm going to force a decision. So now I force a decision, and I forced a decision that has to say that it is either running or it is not running. I made the system do one of two things. It has to output in a dual alternative structure. It has to. There's no option anymore. It has to do it. Okay. So I say multiple alternative. Then I say check with case and see that it's running. And then I can check. So I can do SSHD check equals like 4. And I can run that same one again. And it'll tell me that something's really wrong. But it did that because in 0, in the first option, SSHD was running. But we don't have a 0 anymore. We have it set to 4. In the case of 1, it's going to say SSHD is running. And in all other cases, it's going to say something is really wrong. Boom, there you go. If you've never done that before, there's your logic. That's basic start of logic for our system. Now we hit check, and it says now you've done some basic decision logic. Let's add in an inclusive OR and an exclusive AND to the situation. So we're going to go in and we're going to check if both SSHD and HTTPD are off. So we're going to check both of those. And it says nothing. It gave us nothing because SSHD is not equal to 0. I'm going to set SSHD back to 0 just so our checks are similar again. This is why it's important to know this and be able to do this. If I run this, it's now saying HTTPD is good and SSH is good. So this is where the logic comes in for and. If I say I went to the store and, so I went to the store and I went to the park, but you find out later I only went to one of those two places, did I lie to you? You can do ampersand as well. Yeah, we talked about this yesterday. You could use that as well for our test. Yep. You could break this right here, or you could do it in one. A logical OR looks like this. Boom. And the logical OR will be true either. What they're saying, what Andre is saying is you could do this. So for OR here, I could do this. I could do if this or that, and I would get the same thing. And if I did an and, it would be this. So you could test this either way, right? And you'll get similar types of output to if you do the -a or the O. There's different ways, guys. There's different ways to do it. I just chose to show it that way. And then after you're done and you've done all your tests, I say, look at you learning Linux. More information can be read and worked through here. And when you click on here, it takes you to one of my favorite things on the website to show you guys. Maelstrom, I love that one. Yeah. If you go down to the store, get a gallon of milk. If they have eggs, get 6. And then you show up with 6 gallons of milk, right? This shows you, this is a really good way to walk through, and you could do this in the lab right here and see all of these different pieces. So they have all these different things. You know, you could pop it up over to the side and you could walk through it if you wanted more time and practice in here. But the Linux Documentation Project, TLDP, one of the best things I think around for learning how to do this stuff, right? Okay. So, oh man, I've been on over 3 hours. I didn't mean to be streaming that long today. But let's go to, I'm going to drop down to our end of stream stuff. I appreciate you guys all coming by. You know, we got a Discord. You guys are always welcome down in the Discord. You can always hang out down there and talk shop with other engineers and stuff like that. What else? What else was I going to tell you guys? Yeah, let's go find somebody to raid. Let's see what's going on out there in the world. Let's see if I don't think anybody that I know is on. We can go raid Rossberger. We'll go raid Rossberger. It's changing a little bit. Ranger's doing good. Moop moop. I can't show him on stream right now because I'm on my alternate. But we'll go right over to Rossberger. It's a change of channel. But if you guys are interested in this kind of stuff, you know, hang out down in the Discord. I think I can post the Discord. Hold on, I'm gonna post the Discord over on the other side here for people that want to go get in there. That's on the YouTube side because we got a couple people on YouTube at least. And I'm gonna raid over there, and I will talk to you guys later. Take care.